Welcome to Tell Me Why. To visit any hall, just click on the doorway you want to enter. To walk backwards, use the arrow on the bottom of the screen. The traffic lights let you stop, skip ahead, and use other features of the program. So just click on a doorway to get started.
There I was, minding my own business, sitting on my tuffet, eating my curds and whey. Say, what are curds and whey, anyhow?
I had to make a lot of noise to get a day named after me.
I'm not washed up at all. Come inside. I'll tell you all the dirt.
I came, I saw, I changed the calendar. When you're roaming inside, make a date with me.
If you've ever had the chance to see clothes spin around in a dry cleaning machine, you know that there's some kind of liquid in there. So, why do they call it dry cleaning if it really isn't dry at all? Well, it's called dry because the process doesn't use water. You see, some clothes can shrink or lose their color when washed in water. However, many garments can be cleaned safely with chemicals called solvents, which dissolve stains. Dry cleaners put the solvents and clothes into a machine that looks like a normal washing machine. The clothes are put through a few clean and spin cycles. After that, they're dried. Finally, they're ironed in the big pressing machine. Now, your favorite shirt is as good as new without using a drop of water. Let's say a leaky pen just left its signature right in your shirt pocket. What can you do? Call in a spotter. No, he doesn't put spots in, he takes them out. The spotter analyzes the stain to figure out which chemicals will remove it. Then he cleans the spot with the right chemicals. Nylon stockings can stretch from small, crumpled bundles to fit almost any leg. Where do you suppose this amazingly stretchy yet strong fiber comes from? Well, nylon was the first synthetic fiber ever made. Synthetic means that the material is man-made using chemicals rather than being a natural fiber like cotton or wool. Nylon was first made back in 1938 when a group of scientists were studying the structure of giant molecules. One day, they mixed some chemicals containing carbon, hydrogen, and nitrogen, and they came up with a material that stretched like warm taffy candy. Even more surprising, when it cooled, it got stretchier still, and it was amazingly strong. After working 8 long years, they perfected the textile fiber that we call nylon. Making nylon is a lot more complicated than processing a natural fiber such as lamb's wool. Here's how it's done. Water, air, and chemicals from coal, petroleum, or natural gas are combined to form 2 different kinds of molecules. These then form into one larger molecule, which is called nylon salt. Then the nylon salt molecules are heated in a giant pressure cooker. They're heated until they hook together into a long chain of nylon salt molecules called a polymer. The polymer becomes a thick liquid when heated. Then the polymer is forced through tiny holes in order to form thin fibers. The fibers harden as they cool, and then they're wound together to form a yarn. After this yarn is stretched to 3 or 4 times its length, It becomes strong and elastic, and we have nylon. But one word of caution, this is not a project for your home chemistry set, so don't try to make nylons. It's a lot easier to buy them at the store. Why is it that when you spill ink on a tablecloth, it leaves a bad stain, but when you spill the same ink on your skin, you can wash it right off? The reason is that when you wash, you're really rubbing off a layer of skin and getting to a clean layer underneath. You see, your outer skin has no blood vessels or nerves. Instead, it's composed of 30 layers of dead skin. As we wash off layers on top, other cells replace them from below. So, where does the soap come in? Well, the top layer of skin is covered with an oily substance that mixes with dirt. When you wash, soap forms lots of little bubbles. The surface tension of these bubbles attracts the dirt and removes it. Soap also breaks and dissolves those oily layers. Add a little water to rinse it all away, and you've got clean hands. Soap is a relatively new idea in human history. The ancient Greeks and Romans, for example, depended on massages and sweat baths to clean their skin. And in the Middle Ages, people weren't too keen on cleaning of any sort. In the court of Catherine de' Medici, Queen of France, in the 1500s, there were no bathroom facilities at all. Rooms got so filthy that the court moved 90 times in 6 years so they could clean up dirty rooms. Even the stately Palace of Versailles in France, which was built in the 1700s, had no place to take a bath. It did originally have one bathtub, but it was moved outside and turned into a fountain because no one was using it. So how did they clean themselves? Well, they used a lot of perfume. No kidding, several times a day. Originally, the Egyptians named the 7 days of the week after 5 planets, the sun and the moon. The Romans used the Egyptian system. We get our names for the days of the week from the Anglo-Saxons, the Germanic people who came to populate England. They named the days after their own gods, which were roughly the same as the Roman gods. However, in most languages, you can still find the planets in the names of the days. Pick a day and find out. Sunday was named after the day of the sun, or Sonnendag. In German, it's Sonntag. But the Italian, French, and Spanish use a word that comes from a phrase meaning Day of Our Lord, because in the Bible, God rested on the 7th day. The day of the moon was Monendag, or Monday. In German, it's Montag, but in French, it's Lundi. In Spanish, it's Lunes, and in Italian, lunedì. These words go back to the Roman name for the moon. Wednesday had been named for Mercury in the Roman week, but the Anglo-Saxons named it after their chief god, Woden. That's where we get Wednesday. The Italians, French, and Spanish go back to the Roman. In Italian, it's mercoledì, French, mercredi, and Spanish, miércoles. The Roman day of Jupiter became the day of the Anglo-Saxon thunder god, Thor. Thursday is Thor's Day. In French, it's jeudi, Italian, giovedì, and Spanish, jueves, all using the Roman Jupiter as their base. This day was named after Mars in the Roman week, so in Spanish it's Martes, French, mardi, and Italian, martedì. The Anglo-Saxons dedicated it to Tiu, their god of war, so they called it Tuesdag. The Romans named Friday after Venus, and in French it's vendredi, Italian venerdì, and Spanish viernes. The Anglo-Saxons named it after Frigg, the wife of their god Woden, so we call it Friday. Saturday, the Roman day of Saturn, was translated into Saturnsdag. In French, it's samedi, Italian sabato, and Spanish sabado. "30 days has September, April, June, and November. But have you ever wondered where the names of the months come from? First of all, the Egyptians called them months because their calendar was based on the moon. The Romans changed the calendar a number of times. They had a 10-month calendar. Then, around 700 BC, they added January and February as the 11th and 12th months. However, by 46 BC, the Roman calendar was out of whack again, and all the holidays were happening in the wrong seasons. Emperor Julius Caesar decided to fix things by adding 85 days to that year, instituting the leap year, and changing New Year's Day to January 1st. However, many of the names of the months refer back to the calendar before Caesar changed it. Pick a month to find out where its name comes from. January, the first month of the year, is named after the Roman god Janus, the god of beginnings, endings, and, believe it or not, doorways. That's why Janus has two faces, to keep watch in both directions. February comes from the Latin word Februa, the festival of cleansing and purification. When February was the last month of the Roman calendar, it was the time for purifying the temples and cities to prepare for the new year in March, sort of a Roman spring cleaning. March gets its name from Mars, the Roman god of war. It was the first month of the year all over the ancient world, probably because it was the beginning of spring, a time of planting and renewed growth after the long winter. We don't really know much about this one, but some people think that April comes from the Latin word aperire, meaning to open. Maybe that's because so many flowers bloom in April. Here's another name of uncertain origin. May might be named after the Roman earth goddess Maia, or it could be a month in honor of the maiores, or elders. June was named after Juno, the queen of all Roman goddesses, or it could also have been a month named in honor of juniores, the Latin word for youth. Julius Caesar, who reformed the calendar in 46 BC, decided he deserved to have a month named in honor of himself. July is for Julius. Emperor Augustus, the next emperor after Caesar, fiddled a little bit with the calendar too and gave himself a month of his own. Of course, his month is August. September means 7th month. Remember, we're counting from the old Roman calendar when March was the first month of the year. October means 8th month, counting from the Roman calendar, which had March as the first month of the year. November means 9th month. Of course, nowadays November is the 11th month, but in Roman times it was the 9th. December takes its name from the Latin root deca, meaning 10. Remember, the Romans celebrated New Year's in March, so to them, December was the 10th month. A woman sprints on an Olympic track in Seoul, Korea, and seconds later, an audience in New York City cheers her on. How do those images get transmitted to TV sets on the other side of the world? They get there through communication satellites. These satellites orbit the Earth, receiving and passing along television and other communication signals. Here's how they work. A TV signal is sent or transmitted from a station in the country where the event is happening. The signal is beamed up to a satellite which strengthens or amplifies the signal and sends it to another station. Since television signals can only travel in a straight line and the Earth is round, often several satellites must be used to send the signal from one location to another. That's how we can receive television pictures from any part of the world almost instantly. What keeps a television satellite amplifying and transmitting year after year? There are no plugs, no wires or batteries. Why doesn't it just run out of energy and stop? Because it's powered by one of the strongest and longest-lasting energy sources in the universe, the sun. Satellites are covered with solar cells. These cells collect energy from the sun in order to produce power for all the functions the satellite performs. Today, scientists are trying to find other ways to use the sun's energy because it's cheap, efficient, and can't be used up like the Earth's non-renewable energy sources such as gas and oil. We already use solar energy to heat houses, run pocket calculators, even to fuel experimental cars. Although all the bugs haven't been worked out yet, the idea of solar energy is so promising that it wouldn't be surprising if one day most of our machines, appliances, and electronic gadgets were powered by the sun. Here's a riddle. What do you get when you cross a radio with a telescope? Why, a radio telescope, of course. Regular optical telescopes see light, so they can only show us things within the visible spectrum. But there are many more objects and events that are beyond the realm of visible light, and they give out other forms of energy. That's where radio telescopes come in. They gather energy signals given off by distant stars, and scientists use these signals to figure out information about these stars. This radiant energy is collected on Earth by large dish-shaped receiving stations, where computers determine what kind of energy it is, where it comes from, and analyze what it means. Radio telescopes have even told us about spiraling nebula, exploding stars, and black holes. Scientists can look at the information from radio telescopes either in the form of a chart or as a computer-illustrated picture. Have you ever wondered what keeps a satellite spinning through the darkness of space without falling out of the sky? Well, it has to do with a famous idea called Newton's first law of motion. This law says that an object will continue in a straight line unless something stops it. So, according to Newton, if you were shooting marbles, each marble would move forever in a straight line until it hit another marble, or a wall, or the friction of the floor slowed it down. But what's going to stop a satellite? Why doesn't it just go off forever? Well, the Earth's gravity pulls down on the satellite. So why doesn't it fall back to Earth? The answer is that the satellite has just enough velocity, meaning it's going just fast enough that its forward movement equals the rate it falls due to gravity. As the satellite moves forward, gravity pulls it back into orbit, so it just keeps going around in a circle. So, will satellites stay in orbit forever? The answer is no, because thinking about Newton's first law of motion again, something is going to slow it down. That something is friction. You see, the motion of the satellite through the atmosphere causes friction, and that friction will eventually slow the satellite, just as it would slow a marble rolling across the floor. When the satellite slows enough, it can't keep its orbit, and gravity will pull it back to Earth. But the reason we don't worry about dodging falling satellites is the same reason they fell in the first place: friction from the atmosphere. As they fall, the friction produces heat so great that the satellite usually burns up before it reaches the Earth. A boomerang may look like a harmless toy. It's just a curved piece of hard wood that whizzes through the air in a graceful arc. But did you know that it's actually one of the oldest and most peculiar weapons ever invented? A boomerang is curved at an angle of between 90 and 120 degrees. One side is flat and the other is rounded, and each arm of the boomerang twists slightly in the opposite direction. The pressure of the air on the bulge of the rounded side, together with the twist put on it when it's thrown, makes the boomerang circle back and return to the person who threw it. The native Australians, known as Aborigines, can do incredibly skillful things with boomerangs. They can toss them so that they travel straight for 30 yards, make a circle 50 yards across, and return to the thrower. Although we associate boomerangs mostly with these Australian Aborigines, people have used boomerangs as weapons in many other places, including India, Africa, and the United States. Did you think that all boomerangs return to the thrower? If so, you're wrong. There are two kinds of boomerangs, and only one comes back. The non-return boomerang is nearly straight and heavier than the returning kind. It's used as a weapon, and in the hands of an expert it can really be deadly. And the return boomerang? The native people of Australia sometimes use it for killing birds to eat, but mostly they think of it as a toy. But be careful with boomerangs anyway. They can still hurt someone. A boomerang may look like a harmless toy. Have you ever heard a weather forecaster predict rain because of an incoming low-pressure system? Air pressure is related to the movement of hot and cold, moist and dry air in the atmosphere. We measure air pressure with an instrument called a barometer. The most accurate kind of barometer is a mercury barometer, which uses the rise and fall of mercury to reflect the changing pressure of the atmosphere. In a mercury barometer, atmospheric pressure forces mercury into a vacuum tube until the weight of the mercury is the same as the outside air pressure. We can read the air pressure by looking at the numbered scale measuring the height of the mercury. At sea level, the average height of a column of mercury is 29.92 inches. If air pressure drops, the mercury goes down, and we can predict windy, stormy weather approaching. When the mercury rises, we have fair weather. Mercury is used in barometers because it's the Earth's heaviest liquid, and its movement is very small, so a very small tube can be used. If we used water instead of mercury, we'd need a tube 30 feet high.
A weather forecaster isn't the only one who can use a barometer to predict the weather. Click on the barometer and you can too.
When the barometer reads around 31 inches or more, it means high pressure. Odds are the weather here will remain fair for a while. Around 30 inches of pressure is the average reading on a barometer. The weather here could go either way, giving way to high or low air pressure. A barometric reading of 29 inches or less indicates low pressure. Warm air is rising, being replaced by cold air from below. Looks like storm weather. When an earthquake topples buildings and cracks streets, how do scientists measure its power? They use sensitive instruments called seismographs, which detect movement in the Earth's crust. You see, there are cracks in the upper layer of the Earth's surface. These cracks are called faults. The rocks on each side of a fault constantly rub up against each other as they slowly shift position. The force of that rubbing movement can produce earthquakes. So how does a seismograph measure an earthquake? One type of seismograph is made so that a firmly fixed chart lies parallel to the ground, like a piece of paper. Above it is a rod with a weight on it, and attached to the weight is a pen which just touches the chart. When there's an earthquake, the chart moves along with the movement of the earth, but the suspended weight doesn't move. The pen draws lines on the chart as it moves, giving us a visual record of an earthquake. An earthquake's strongest point is always the place on the Earth's surface where the shifting actually takes place. This point is called the epicenter. A seismograph can pinpoint the epicenter by measuring two kinds of seismic waves called P and S waves. These waves travel at different speeds through the Earth. Calculations based on the time of arrival of each of these waves at the seismology station tell scientists where the earthquake was centered. And there are different kinds of seismographs to record different kinds of earthquakes. In some quakes, the earth moves horizontally from side to side, and in others it moves vertically or up and down. Today, scientists are very interested in trying to predict earthquakes. By looking at seismographic records of past quakes and by studying day-to-day records of activity at fault lines, they hope to discover patterns that will help them predict quakes. If they can tell when a quake is coming, they can warn people to take steps to protect themselves. The word thermometer comes from the words thermo, meaning heat, and meter, to measure. So a thermometer measures heat. Mercury is the perfect material for a thermometer because heat makes mercury expand and rise. Mercury will always rise to the same point when the same amount of heat is applied. To make a thermometer, a small amount of mercury is put into a tube with a bulb at the bottom. The upper part of the tube, the part without mercury, is either left as a vacuum or filled with gas. Then a numbered scale is added to tell us the level of mercury. When you use a thermometer, the heat that your body is producing makes the mercury in the thermometer rise. If your body produces just 2 degrees more heat than normal, the mercury will go up 2 degrees from 98.6 to 100.6. Many modern thermometers don't use mercury anymore, but they still register the rise and fall of body heat. And a note of caution: mercury and its vapors are highly toxic, so don't experiment with it unless you have supervision. There are 2 main measurement scales used to describe temperature. The Fahrenheit scale is used mostly in the United States, while the Celsius scale, also called centigrade, is preferred in countries that use the metric system, such as countries in Europe. On the Fahrenheit scale, water freezes at 32 degrees, whereas it freezes at 0 degrees on the Celsius scale. Water boils at 212 degrees Fahrenheit and 100 degrees Celsius. There's an easy way to convert Fahrenheit to Celsius so you can read both types of thermometers. Start with the Fahrenheit reading, subtract 32, and multiply the answer by 5/9, 5/9. You'll find that 75 degrees Fahrenheit equals about 24 degrees Celsius. To go from Celsius to Fahrenheit, multiply the original number by 9/5, then add 32. So if you hear that it's 15 degrees Celsius in London and 59 degrees Fahrenheit in New York, you'll know that both places are the same temperature. Have you ever been told that you're letting out the cold when you leave the refrigerator door open? How do you suppose the cold gets in there in the first place? Well, chemical substances called refrigerants, such as freon and ammonia, are circulated through tubes in your refrigerator. When these refrigerants change from gas vapors into liquid, heat is released. Here's how it works. First, a pump compresses the vapor like a bicycle pump compresses air. This heats up the vapor, which is then sent to the condenser. The condenser turns the vapors into a very cold liquid. This produces heat, which is released outside the refrigerator through the coils of the condenser. The cold liquid now flows to the evaporator, which is the compartment that cools the contents of the refrigerator. The heat in this space is slowly absorbed, causing the liquid to evaporate back into a vapor. It returns to the compressor and condenser, where the heat once again escapes to the outside, and the cycle is repeated over and over. If you wanted to sample every cheese made in the world today at the rate of one variety each day, it would take you more than 5 years. That's because there are over 2,000 varieties of cheese made around the globe. But all of them come from just 3 main types of cheese: hard cheeses like cheddar, soft ones like cream cheese, and blue cheeses like Roquefort. Some countries are famous for their cheeses. Brie is a well-known cheese from France. Parmesan is a cheese made in Italy. The United States is known for its American cheese, of course, but also for some of its cheddar. The U.S. produces more than 1 million tons of cheese each year, most of it from Wisconsin. Do you know where your favorite cheese comes from? Click on a country to find out what kind of cheeses are made there. It's no surprise that American cheese is made in the United States, but did you know that some famous cheddar is too? From England, we get famous hard cheeses like cheddar and Stilton. Edam and Gouda are delicious cheeses from Holland. In France, they often eat camembert and brie for dessert. The Swiss are particularly fond of their Emmentaler and Gruyere cheeses. Do you sprinkle Parmesan or Romano cheese on your spaghetti? If so, you're using an Italian cheese. Remember Little Miss Muffet eating her curds and whey? Did you know that she was actually eating something like cottage cheese? Cheese was one of the first manufactured foods, and the method for making it was probably discovered about 3,500 years ago by accident. All cheese starts out as milk. When certain bacteria or fungus is added, the milk forms into a soft curd and its flavor changes. This is called curing. Then rennet, an enzyme from the stomach of a calf or sheep, is added to make the milk into a firm curd. The curd is cut and the water, or whey, is drained. Then the curd is salted and the last of the whey is pressed out. The curd is put into molds and cured some more. And what comes out is hard or soft, sweet or smelly cheese. You can make cottage cheese in your own kitchen. You'll need to use the stove, so it's best to have an adult around to help. First of all, you'll need a pint of buttermilk, a pan, and some cheesecloth. Now click on the numbers and follow along. Heat the buttermilk slowly in the pan until the whey rises to the top. It'll look like milky water. Carefully pour off the whey. What's left is the curd. Wrap the curd in cheesecloth and let it drip in the sink or over a bowl for about 6 hours. Put the curd in a bowl and break it up into small pieces. Now add salt if you like and put the bowl in the refrigerator. Wait until it's cold. That's it. You now have cottage cheese for you and your friends. When we think of the tiny living creatures known as bacteria, we usually think of infection and disease. But some bacteria is actually useful. In fact, bacteria is used to give Swiss cheese its holes and its sweet nutty flavor. Harmless bacteria and molds are allowed to grow on cheese while it's held in storage under controlled conditions. This is called curing. In Swiss cheese, bacteria grows and gives off gases. These gases form the round holes or eyes that make Swiss cheese so familiar. By the way, bacteria and molds are also used in other cheeses. For instance, a mold in blue cheese gives it a bluish color and a very strong flavor. All cheese starts from milk, but you'd be surprised at all the different kinds of milk people use. Click on the map to find out how cheese is made in other countries. There are lots of reindeer in the Arctic, right? So they make their cheese out of reindeer milk. Most cheese in the United States comes from cow's milk. There are lots of reindeer in the Arctic, right? The ancient Greeks often used horse's milk for cheese. Today, Greeks prefer to use goat's milk. In Mongolia, camel's milk is the base for cheese. In many parts of Asia, sheep's milk is the main ingredient in cheese. In many parts of Asia, sheep's milk is The Tibetans use yak milk to make cheese. What do you suppose that tastes like?
Step into the rings with me.
Why should you come inside? Because it's there.
Take one small step inside to find out more about life on the moon. I got squared away when I made short stuff of that French guy.
Can you imagine building Egypt's pyramids with no cranes, forklifts, or trucks, with little more than your bare hands? Some of these enormous stone tombs are almost 500 feet high. In the Great Pyramid at Giza, for example, there are over 2,300,000 blocks of stone. Each block is as big as a large room in a house. The largest are 7 feet high and 18 feet across. It's said that 100,000 slaves labored for 20 years to build the Great Pyramid. Each of the 2-ton blocks of limestone or granite was brought by boat across the Nile River and pulled on sledges along a road from the docks to the building site. Now, as the pyramid grew higher, slaves pulled the stone blocks up ramps to the top. The inside blocks were left rough, but the outside ones were very smooth and even. And the pyramids were so well constructed that you can still see them today if you ever visit Egypt. The pyramids were designed for a special purpose: to preserve the bodies of Egyptian kings or pharaohs. The Egyptians believed in life after death. They thought that their future life depended on keeping the body well preserved. So pharaohs' bodies were mummified and hidden in special rooms below ground in a pyramid. Food and other necessities of life were buried with them. The pyramids were designed with many rooms and false passages in order to confuse would-be grave robbers. Archaeologists think the pyramids were built around 2500 BC. We know for sure that the Great Pyramid at Giza was built by the pharaoh Cheops somewhere around that time. And the Egyptians weren't the only culture to have pyramids. They were also built by people as close as Greece and as far away as Mexico. The ancient structure at Stonehenge is one of the world's great mysteries. What are these massive rocks perfectly aligned to the heavens? Stonehenge, which stands near Amesbury in England, is a structure of upright stones and ditches placed in a circle. The stones are set in 2 circles and 2 horseshoes of upright stones. Some of the separate stones have been given fanciful names, such as the altar stone and the slaughter stone. Some of them feature primitive engravings, such as these daggers and axes. Cremated human bones have been found in pits located around the structure. Legend has it that the stones were magically transported from Ireland by Merlin the magician. But today, scientists know that parts of Stonehenge date back to about 2800 BC. Most now think that Stonehenge was built by the Stone Age and Bronze Age farmers and herdsmen of southern England. It's true that no one knows why Stonehenge was built, although people have been fascinated by it for a long time, and they have come up with several theories. For example, it's known that parts of Stonehenge are aligned so that the midsummer sun rises at a particular point. Some people also noticed that the positions of the stone blocks can be used to measure the movement of the sun and moon and are aligned with eclipses. So they theorized that Stonehenge might be some sort of solar calendar. But what about the cremated bodies in the pits? Was it a religious site or perhaps a graveyard? Most people think that Stonehenge was a sacred enclosure, combining religious, scientific, and social aspects of life in prehistoric Britain. But beyond that, we may never discover the meaning behind the mystery of Stonehenge. Imagine yourself roller skating down the sidewalk or soaking in a hot bath, when suddenly everything stops and freezes, like in a photograph. That's just what happened to the city of Pompeii. On August 24, 79 AD, the southern Italian volcano Vesuvius erupted, covering Pompeii with ashes 18 to 20 feet deep. When water came down on the ashes, the material became like clay, leaving everything exactly as it was before the eruption. Pompeii was forgotten until 1763, when excavation started. Over the years, archaeologists have found remains of entire families going about their daily lives and ovens with loaves of bread still in them. The houses, roads, and theaters, everything is just as it was. By exploring the ruins of Pompeii, archaeologists have been able to arrive at an accurate picture of life almost 2,000 years ago. Did you know that when it's 12 noon in Paris, it's only 3 a.m. in Los Angeles? Well, that's because Paris and Los Angeles are in different time zones. Time zones are based on lines of longitude. As you move east from Greenwich, England, you add 1 hour for every line of longitude. As you move west, you subtract 1 hour. So when it's 12 noon in Greenwich, it's 7 a.m. in New York, 5 lines of longitude away. Time zones aren't set in straight lines, however. That's because individual states and countries choose which time zone they use. On the opposite side of the world from Greenwich is the International Date Line. Cross it going west and you lose a day. Cross it going east and you gain a day. So if you were at the International Date Line on your birthday, you could celebrate one day, cross the line, and celebrate again. Now take a look at this map. By clicking on a city, you can find out what time it is there when it's noon in New York. It's 9 a.m. in Los Angeles. Surf's up. It's 11 a.m. in sunny Guatemala. It's noon in the Big Apple, New York City. It's 2 p.m. in Buenos Aires. Time for a siesta. We say 6 p.m. in Paris. It's 5 p.m. in foggy London. It's 7 p.m. in Greece. Pass the feta cheese, please. It's 8 p.m. in Moscow, comrade. It's 10:30 p.m. in India. Pass the puri, please. It's 1 a.m. in Hong Kong. Time for a rickshaw ride home. It's 2 a.m. in Japan. Do you have a yen to go to sleep? It's 3 a.m. in Sydney, Australia. Good morning, mate. Meanwhile, in New Zealand, it's a sleepy 5 a.m. What's the point of all those lines that crisscross the world map? Well, they're imaginary lines which we use to describe the exact location of anywhere on Earth. The lines going east and west are called parallels of latitude, and the lines going north and south are called meridians of longitude. Lines of latitude and longitude are numbered by degrees. The line for 0 degrees latitude is at the equator, another imaginary line which circles around the center of the Earth, like a belt. Every 15 degrees north and south of the equator is another line of latitude. 0 degrees longitude is on a line that goes through the English city of Greenwich. This line is called the prime meridian. Again, every 15 degrees east and west of prime meridian is another line of longitude. To get even more precise measurements, each degree of latitude and longitude is divided into 60 minutes and each minute into 60 seconds. Here's a map showing some major cities of the world. Pick one to find out its latitude and longitude. Los Angeles, California is at 34 degrees 3 minutes north latitude, 118 degrees 15 minutes west longitude. Mexico City, Mexico is at 23 degrees 0 minutes north latitude, 102 degrees 0 minutes west longitude. New York City is at 40 degrees 43 minutes north latitude, 74 degrees 1 minute west longitude. Buenos Aires is at 34 degrees 36 minutes south latitude, 58 degrees 27 minutes west longitude. London, England is at 51 degrees 30 minutes north latitude, 0 degrees 10 minutes west longitude. Paris, France is at 48 degrees 52 minutes north latitude, 2 degrees 20 minutes east longitude. Rome, Italy is at 41 degrees 54 minutes north latitude, 12 degrees 29 minutes east longitude. Johannesburg, South Africa is at 26 degrees 10 minutes south latitude, 28 degrees 2 minutes east longitude. Jerusalem in Israel is at 31 degrees 46 minutes north latitude, 35 degrees 14 minutes east longitude. Moscow, Russia is at 55 degrees 45 minutes north latitude, 37 degrees 35 minutes east longitude. Beijing, China is at 39 degrees 55 minutes north latitude, 116 degrees 25 minutes east longitude. Tokyo, Japan is at 35 degrees 42 minutes north latitude, 139 degrees 46 minutes east longitude. Sydney, Australia is at 33 degrees 52 minutes south latitude, 151 degrees 13 minutes east longitude. Imagine a whirling tower of wind so powerful that it can snatch up cars and carry them for miles. How do tornadoes, those destructive wind demons of nature, get started? Well, a tornado is a special kind of storm where winds circle round and round toward the center of an area of low pressure. A tornado begins with rising air and winds that blow in opposite directions. Now this starts a violent spiraling effect. Then centrifugal force throws the air away from the center, leaving a narrow core of low pressure in the middle. This low-pressure core acts like a powerful vacuum on everything it passes. Winds up to 300 miles an hour can collapse walls of houses and destroy everything in their path. Most people who live in tornado areas take refuge from the storm in underground storm cellars that keep them safe until the storm passes. Tornadoes are sometimes called cyclones or twisters, and you can actually see the twisting column of air and dust from miles away. In the U.S., tornadoes occur most frequently in the central states, where they travel in a northeasterly direction at 20 to 40 miles an hour. Fortunately, they usually travel for only a few miles and have a fairly narrow path. Even so, tornadoes cause a lot of damage wherever they touch down. Entire towns have been destroyed by big ones. Oh, by the way, in the northern hemisphere, most tornadoes spin counterclockwise. And in the southern hemisphere, they usually travel clockwise. Have you ever heard someone say that he was in the eye of a storm? Well, it means he's in the center of all the action, just as the eye of a hurricane is in the center of that fierce tropical storm. But the eye of a hurricane is still and calm, not violent at all. It's the rest of the hurricane that's so ferocious. A hurricane is a huge storm, 25 to 600 miles wide, with winds up to 200 miles an hour and driving rain. The eye of a hurricane is a small area of very low pressure in the center of the column of spiraling wind. The eye is usually about 10 to 20 miles wide, and in the eye, the sky may be blue and there may be only a light breeze. If you were in the eye of a hurricane, you might think the storm was over, until the winds began to blow again from the opposite direction. Has anyone ever said you were in the doldrums when you were acting tired or sad? Well, there really are places called the doldrums, and they're where many hurricanes start. The doldrums are areas in the Atlantic and Pacific Oceans near the equator. They're called the doldrums because air is always blowing upwards in this region, and early sailors were unable to sail in the listless winds. Hurricanes begin when the moist air near the water rises and is replaced by cooler, thicker air which blows inward in a spiral. By the way, hurricane is the name people give to these storms when they start in the Atlantic or eastern Pacific regions. The word comes from the West Indian word huracan, which means big wind. But if the same kind of storm starts in the western Pacific area, it's called a typhoon, from the Chinese word typhon, which is just another way of saying big wind. If you've ever felt an earthquake, you know that the trembling or vibration of the Earth's surface can be a pretty scary experience. Earthquakes occur because there is continual sliding and breaking of the brittle crust at the surface of the Earth. A place where two sections of crust move against each other is called a fault line. Sometimes the sides move up and down, and sometimes they move lengthwise. This movement produces an enormous amount of energy, which is changed into vibrations in the rocks, and we feel it as an earthquake. The vibrations may travel for thousands of miles through the Earth, sometimes splitting it with long, deep cracks. Some earthquakes cause a tremendous amount of damage, while others feel no worse than a short roller coaster ride. Large earthquakes are often followed by aftershocks, quakes caused by the first trembler that can come minutes, days, or even years afterwards. Scientists measure the intensity of an earthquake with an instrument called a seismograph. There are two scales of measurement that are used to figure out how strong the quake was. One scale is called the Mercalli scale, and it goes from a small quake, a number 1, to the largest at number 12. The Richter scale, named after its inventor, Charles Richter, measures quakes on a scale that starts at 1 and goes on forever. But every whole number on the Richter scale is 10 times higher than the number before. So a 2-point earthquake is 10 times stronger than a 1-point. And a 4-point quake is 1,000 times stronger than a 1-point. An earthquake that measures 6 or over on the Richter scale is considered dangerous. In 1980, the American volcano Mount St. Helens erupted for the first time in 123 years. It blew out an entire side of the mountain and spread black ash into towns 85 miles away. Volcanoes form because the temperature under the surface of the Earth gets hotter as you go deeper. At a depth of about 20 miles, it's hot enough to melt most rocks. As rock melts, it expands. This liquid rock, called magma, forms into reservoirs under mountains. The magma rises up through the cracks in the earth, and when the pressure becomes too great for the surface rock to bear, it bursts through as a volcano. The crater, the deep hole in the middle of the volcano, is where the opening reaches the surface and the magma spews out. Temperature and pressure at the surface change the magma into lava. Rivers of lava have been known to bury entire cities. Most people think that planets are discovered by accident, but scientists actually went looking for Neptune and Pluto, and they were pretty sure where they'd be. You see, we know that planets are pulled, not just by the sun's gravity, but by the gravitational pull of other nearby planets. Armed with this knowledge, two scientists in 1846 saw that there was something peculiar about the orbit of Uranus. At that time, Uranus was the outermost known planet, but its orbit indicated that it was being pulled by something even farther away. So they figured out where the unknown planet should be, and sure enough, there was Neptune. But the orbit still looked odd, and Neptune's orbit wasn't quite right either. People started searching for yet another distant planet, and in 1930, Pluto was discovered. Today, some scientists think there may even be a planet beyond Pluto, which for now they're calling Planet X. There are two scientific laws that helped people figure out that there were more planets past Uranus. These laws are Kepler's law of planetary motion and Newton's law of gravity. Kepler's law of planetary motion says that planets' orbits around the Sun are not perfect circles. Newton's law of gravity explains that two objects attract each other depending on the amount of mass in each object. Mass is how much matter each object has in it. Attraction also depends on how far apart the objects are. The greater the mass, the stronger the pull, and the closer together they are, the stronger the pull. Using these laws, scientists recognized that there had to be something of great mass pulling at the orbit of Uranus. And of course, that mass was the planet Neptune. Since the beginning of time, legends have been passed along about life on the moon, from Roman gods to the man in the moon. But long before the moon was explored, scientists realized we wouldn't find any life there. This is how they figured it out. The moon has no twilight. 1 minute it's light, and the next minute it's dark. Here on Earth, we do have twilight. Twilight is created as our atmosphere reflects the sun's rays even after the sun is set. So because the moon has no twilight, scientists knew that there was no atmosphere on the moon. Nothing to protect it from the sun's harmful radiation and heat. Nothing could live in that kind of environment. During a moon day, which lasts a full 2 weeks, temperatures soar to 300 degrees Fahrenheit. And at night, which also lasts for 2 weeks, temperatures can get down to 260 degrees below zero. On July 21, 1969, 2 American astronauts, bundled in heavy spacesuits and moon boots, took the first steps on the surface of the moon. From their orbiting Apollo 11 spacecraft, they flew down to the lunar surface in a landing module called the Eagle. The world watched as Neil Armstrong slowly climbed down and planted his feet on the dust and rocks of the moon. These were his words at that historic moment.
It's one small step for man, one giant leap for mankind.
It had taken 8 years and $25 billion to achieve this lunar landing, and it was cheered on by the millions of people around the world glued to their televisions. Minutes later, Edwin Aldrin Jr. joined Armstrong on the moon. The astronauts returned with moon rocks and soil samples, and the one thing that we had waited for eons, a first-person look at the moon. Light travels faster than anything we know, but a Danish astronomer was able to figure out its speed over 300 years ago with little help from Jupiter. Back in 1676, Olaus Remmer was watching as one of the moons of Jupiter passed behind the planet, became eclipsed, and reappeared on the other side. Remmer recorded these eclipses as they occurred over and over. He noticed that the length of time between these eclipses got shorter as Jupiter and Earth moved closer together, and then longer as the Earth moved away again. There was about 17 minutes difference. Well, Remmer realized that when the 2 planets were far apart, the eclipse's light took longer to get to Earth. That meant that the distance the light traveled was what actually made the eclipses seem early or late. Using the 17-minute time difference and the known distance between Earth and Jupiter, he came up with a rough figure for the speed of light. Olaus Remmer calculated that light must travel at about 135,000 miles per second. In the early 1900s, Professor Albert Michelson determined a more exact speed of light, 186,282 miles per second. So Remmer's calculations were somewhat off, yet it's still remarkable that he came so close without using any modern tools or instruments. But what does the speed of light mean to us? Well, the Sun is 93 million miles from Earth. That's about 8 light minutes away. Now, this means that the light you see right now was sent from the Sun 8 minutes ago and has been traveling through space on its way to Earth for 8 minutes. And perhaps you've heard the term light year. Well, light year is actually a measurement of distance, not of time. If you take the light speed of 186,000 miles per second and multiply it by the number of seconds in a year, we find that light travels 5,880,000,000,000 miles in a year. That distance is a light year. Saturn is probably the easiest planet to recognize because it's surrounded by those colorful rings. In 1610, when Galileo first noticed Saturn's rings, he thought they were 2 fuzzy moons. Then, in 1655, Christian Huygens studied Saturn with a better telescope and saw the rings more clearly. There have been many theories about the rings of Saturn, but not until the spacecraft Voyager 1 sent back pictures in 1980 did we realize how complex they really are. The rings seem to have 7 major divisions and hundreds of thousands of subdivisions, well, like the grooves on a record. They're made mostly of ice in all sizes, from chunks and boulders down to tiny chips, all herded closely together in a narrow band that's less than 1 kilometer wide. Scientists think the rings may be the remains of a moon that exploded, or possibly interplanetary matter that drifted into Saturn's gravitational pull. It's often true that the more we learn about Saturn and the other planets, the more questions we have. For instance, Voyager 1 showed us close views of Saturn that man had never seen before. But now these pictures have got us wondering. One strange phenomenon seen in the Voyager photos were dark, fast-moving spokes in Saturn's rings, changing shape, then disappearing, as if the rings were a great spinning wagon wheel. Another odd thing was a narrow ring that looked for a while as if it were 3 or 4 ringlets braided together. These two curious effects are still mysteries, but perhaps one day you'll be the one to solve them. Ever since astronomers noticed a network of what looked like canals crisscrossing Mars, many people have imagined an advanced civilization living on Mars. But when Viking 1 landed on Mars in 1976, it was determined that the canals were only optical illusions. Instead of a Martian civilization, we saw photos of a windswept, rock-strewn, reddish desert. Even the sky was red because of the iron particles in the very thin atmosphere. The atmosphere is nearly 100 times thinner than Earth's, and it's mostly carbon dioxide. We Earthlings certainly couldn't live in that atmosphere, and neither could any other similar form of life. We also learned that Mars has polar ice caps and definite seasons, as Earth does. There's no liquid water on Mars, again because the atmosphere is too thin, and it gets terribly cold there, from a high of 0 degrees during the day down to 150 below at night. Even though Mars is about half the size of Earth, a Martian day is just 37 minutes longer than our Earth day because it rotates more slowly. But a Martian year, the time it takes Mars to orbit the Sun, is almost twice an Earth year. 1 year on Mars is 669 Earth days. If we thought of that in our normal calendar months, each month would have about 55 days. We already know that the Martian atmosphere is thin. A jet plane flying at about 100,000 feet would be in a similar kind of atmosphere, and so would a mountain climber going straight up 20 miles. But because there's so little oxygen in the atmosphere, a person would suffocate in only 30 seconds or so. And if the atmosphere or extreme cold didn't get him, the ultraviolet rays of the sun would. Because the rays come through the very thin atmosphere, they would severely sunburn a human body in just 15 minutes. Did you know that buried inside every seed is everything it takes to sprout a whole new plant? If you split open a large seed, like a bean seed, it divides into 2 pale, thick leaves called cotyledons. You'll also see a tiny white sprout at one end, between the cotyledons. The sprout is the future bean plant, and the cotyledons, which are filled with starch, are the stored food that will nourish the plant. Not all seeds look like this. Some, such as corn, have only 1 cotyledon. Some sprout as soon as they fall from the plant, though most need a rest period, which is usually in the winter. Seeds found in fleshy fruits like apples or tomatoes don't sprout until they're removed. That's because the fruit contains certain substances that prevent them from sprouting. This field might appear to be one of the most peaceful places on Earth, but actually those plants are hard at work making their own food through a natural process called photosynthesis. Inside each leaf are hundreds of little cells containing many small structures called chloroplasts. Inside the chloroplasts is a green substance called chlorophyll. That's what makes leaves green. Here's how it works. First, the sun hits the leaf and passes through to the chlorophyll. Meanwhile, water is carried up from the roots through the trunk or stem into the leaves and into the chloroplasts. The leaves absorb carbon dioxide from the air and pass it on to the chloroplasts. Sunlight causes the water to separate into oxygen and hydrogen. The oxygen isn't used by the plant and is released into the air. The hydrogen combines with the carbon dioxide to make a kind of sugar. That sugar is the plant's food. Plants can't use all of their food at once, so they use some and store the rest. Plants that store a lot of sugar produce very sweet fruits or sap, like maple sugar. In winter, when the leaves die and photosynthesis can't take place, the plant lives off its stored food until spring. But if plants use their leaves to make food, what are the roots for? Although the leaves are where the food-making process takes place, the roots of a plant are just as important to its survival. The roots absorb water and carry its nutrients to the leaves for the food-making process. So the next time someone tells you that plants get food from their roots, you can tell them they're almost right. The roots bring in some of the ingredients needed to nourish a plant, but the leaves are where the real action takes place. Perhaps you've seen mushrooms pop out of nowhere in your front yard, as if by magic. Well, mushrooms grow from spores, tiny single-celled dust-like particles that shed from mature mushrooms. Each mushroom produces thousands of spores which are carried by the wind. If they land in warm, moist spots that have plenty of food, the spores will grow into mushrooms. The part of the mushroom we see above ground is only the fruit. Underground, a mass of tiny white threads called mycelium grow from the spores and absorb food from the surroundings. At various points, little balls no bigger than pinheads develop. They push upward and break out of the soil into the familiar umbrella shape. Since mushrooms have no chlorophyll, most of them don't need bright sun. In fact, they prefer shady, warm, and wet places. What do mushrooms, mildew, bread mold, and athlete's foot have in common? Well, they're all caused by fungi. Fungi is plural for fungus. There are fungi that produce molds, like bread mold and potato blight. Athlete's foot is also caused by a fungus, but fungi can also be very helpful. For instance, we get the antibiotic penicillin from a fungus, and the yeast that makes bread rise and beverages ferment is also a fungus. But perhaps fungi's greatest job is to rot dead trees and leaves so their minerals and nutrients can blend back into the soil to nourish the growth of new plants. Without fungi, dead trees would just clutter up the forest and the soil wouldn't get nutrients. New trees and plants couldn't grow without the help of the strange little organisms we call fungi. Perhaps you've never heard of Simón Bolívar, but his record of leading revolutions for independence in half a dozen South American countries earned him the name El Libertador, the Liberator. Bolívar was born in Venezuela in 1783, a time when most of South America was under Spanish rule. Though his family was rich, he sympathized with the common people. He was greatly impressed by the freedoms won in the American and French revolutions. In 1811, he and a group of patriots declared Venezuelan independence from Spain, but the uprising was crushed and he fled the country. 8 years later, he led the Colombians to independence. Within 3 more years, he had freed both Venezuela and Ecuador. As president of the union of those countries, called Gran Colombia, he helped liberate Peru. Upper Peru was named Bolivia in his honor. When Gran Colombia fell apart, Bolívar resigned as president. By then, he had many enemies, and he died a disappointed man in 1830. Although he never fulfilled all his dreams, he is considered to be as important to South America as George Washington is to the United States. There are some leaders whose names alone are symbols of an era. Such a man is Napoleon Bonaparte. Napoleon was born in Corsica in 1769. By the time he was 16, he had graduated from the military academy in Paris. When he was just 24, he became a brigadier general in the army and led his men to many victories. Napoleon gained great fame and honor and became first consul or ruler of France. Then, in 1804, he proclaimed himself Emperor of France. During his 10 years as emperor, France was almost always at war. In 1812, Napoleon invaded Russia, but he didn't have enough supplies during the long, cold Russian winter, so his army had to retreat. After losing several more battles, he was finally removed as emperor and was exiled to the Isle of Elba. Napoleon escaped from Elba and returned to fight again. But he lost to the British at the famous Battle of Waterloo, and this time he was sent to the barren island of St. Helena. Napoleon died there in 1821. There were few leaders of the time who could match Napoleon's military ability, and those who could were, for the most part, British. One was Admiral Horatio Nelson, who destroyed the Napoleonic fleet of ships at the Naval Battle of Trafalgar off Spain on October 21, 1805. This ended Napoleon's power at sea. Nelson himself was killed in that battle, and a memorial statue of him stands today in Trafalgar Square in London. Another Englishman, the Duke of Wellington, defeated Napoleon at the Battle of Waterloo on June 18, 1815. After Waterloo, Napoleon was sent into permanent exile. Even today, when someone speaks of meeting his Waterloo, it means that he is in a situation where he is doomed to be defeated. Nearly 100 years after Abraham Lincoln freed the slaves in the United States, Dr. Martin Luther King Jr. led a civil rights movement dedicated to equal rights and opportunities for people of every color. In the 1950s, and for most of American history, blacks had little chance for good jobs, education, or housing. There were laws keeping blacks and whites separate and denying blacks the opportunities that white people had. Dr. King believed that this needed to be changed. He led blacks and whites together on many marches and protests. Dr. King's many followers influenced Congress to pass the Civil Rights Act in 1964, assuring blacks and other minorities of the rights promised to everyone in the Constitution. In that same year, Dr. King won the Nobel Prize for Peace. One of the most memorable events of the Civil Rights Movement was the March on Washington. In 1963, Dr. King led an enormous crowd of blacks and whites in a massive march on Washington, D.C. to support civil rights and jobs for all. All of the protesters were nonviolent because Dr. King believed that equality could only be reached through peaceful means. 250,000 marchers gathered at the Lincoln Memorial that afternoon and heard Dr. King deliver the now famous "I Have a Dream" speech. The entire world was deeply shocked when Dr. Martin Luther King Jr. was assassinated on April 4, 1968. He was only 39, but he had awakened millions of Americans to the realization that a free country means equal opportunities for all citizens.
I thought I knew why giraffes had long necks, but I was off la marque. Who am I? Find out inside.
Hey, rattle my cage. I'll show you around poisonally.
When I have a grisly encounter, I just grin and bear it.
Tea time? Do you take one hump or two?
Why is the giraffe's neck so long? Scientists don't really know. French zoologist Jean-Baptiste de Lamarck thought that perhaps the giraffe's neck was once much shorter and grew to reach the upper branches of trees so the animal could eat the leaves there. Modern scientists disagree. Our current theory of evolution, based on the work of Charles Darwin in the late 19th century, says that giraffes which were born with longer necks lasted longer because they could reach the food supply. This helped them survive over time, while their shorter-necked cousins starved and died off. The giraffe's neck has only 7 vertebrae, the same number as you, but each vertebra is very long. That's why the giraffe always has a straight neck. A giraffe's tongue is 1.5 feet long, and its aim is so accurate that it can pick leaves off thorny plants without being pricked. The giraffe is such an unusual animal that even the ancient Greeks and Egyptians marveled at it. They thought it was a mixture of a camel and a leopard, so they called it a camel leopard. The spotted coloring of the giraffe's skin hides it well in the shadows of trees. Its hearing, sight, and smell are very well developed, so the giraffe is very alert to danger. When it's being chased, a giraffe can run up to 28 miles per hour. And if it has to fight, it can give some very hard kicks with its hind legs, or butt its enemy with its head. Even a lion is careful in attacking a giraffe and always approaches it from behind. Though some rhinoceroses can reach the weight of a medium-sized truck, they're usually quiet, slow-moving animals with little interest in fighting. Of course, very few animals would try to tangle with a rhino. There are actually 5 kinds of rhinoceroses living today. The black rhinoceros and the white rhinoceros live in Africa. The white rhinoceros is the largest. It's the one that can weigh over 3.5 tons, and it can reach up to 6.5 feet tall. The other 3 kinds of rhinos live in Asia. 2 of them, the Javan and the Indian rhino, have 1 horn each. The Sumatran rhino has 2 horns and is the smallest of them all. It usually weighs less than a ton and grows to only about 3.5 feet tall at the shoulder. When attacked, rhinos can charge at up to 30 miles per hour and can do a lot of damage with their horns. The massive rhinoceros eats only grass and other plants, but then again, it might have to mow your whole lawn with its teeth in order to satisfy its appetite. The skin of the rhino is tough and thick, and the rhino's only hair is near its ears and the tip of its tail. Sometimes the horn of the rhinoceros can grow very long. The longest one measured was 62.5 inches. Despite what most people think, the horns aren't made of bone, but of tight clumps of tough hairs. Sadly, many poachers are illegally killing rhinos for sport or to make money. As a result, some rhinos, particularly the Javan rhino, are now in danger of extinction. To conserve such wildlife, many countries have passed laws to protect them and have set aside special wildlife parks for rhinos and other wild animals to live in. The camel is often called the ship of the desert because it's perfectly designed to live in the hot, waterless desert just as a ship is designed to be on the sea. The camel's most distinguishing feature is its hump. This is where it stores food for long trips. Before a trip, the camel spends a lot of time eating and drinking. It eats so much that a hump of fat, weighing perhaps up to 100 pounds, rises on its back. That fat is stored food for the camel, who can then go a long time without eating. By the end of a trip, the hump will be soft and floppy because there's no fat left in it. Camels also have little flask-shaped bags that line their stomach walls. This is where they store water for a long trip. Using the water in its stomach, a camel can go for several days without drinking. And that's exactly what it has done for the 3,000 years that we've used camels as beasts of burden. Did you know that there are two kinds of camels? You can tell them apart by the number of humps they have. The dromedary is a one-humped camel. They used to live in an area spanning from India to North Africa, but you can no longer find them in the wild. The Bactrian is a two-humped camel, native to China, Afghanistan, and Mongolia. It's used as a beast of burden in many other areas, too. Camels are wonderful pack animals for the desert. Not only can they go for long periods without food or water, but their hair protects them from blowing sand, and they can carry very heavy loads. One word of caution, however. Camels aren't always the most friendly or cooperative of beasts. If they're annoyed, they'll spit at you. If you have any idea how large and ferocious most bears are, you may question the famous legend of how the Western scout, Daniel Boone, supposedly killed a bear by grinning it to death. He was probably smiling because he knew that his trusty shotgun would do the job if his pearly whites didn't. Not many people want to tangle with bears because bears are strong fighters and can be very dangerous. And they can be huge. The largest is the Alaskan brown bear. Some of the males weigh up to 1,500 pounds and may be 9 feet tall when they stand on their hind legs. A good-sized polar bear or grizzly bear can get up to 900 or 1,000 pounds. On the other hand, the Malaysian or sun bear is the smallest of all bears and reaches a weight of only 100 pounds. If you were the size of a bear, 3 meals a day might seem like tiny snacks. A bear has to eat a lot of food. Bears are omnivorous, which means they eat all kinds of food, from honey, insects, and fish to other animals. In the United States, the most common bear is the black bear, which lives in wooded and mountainous areas. Bears have poor eyesight, fair hearing, and an excellent sense of smell. They may look clumsy, but they're actually very fast runners and strong swimmers. Bears are most active at night, but in the cold winter, most of them hibernate or sleep day and night. Bear cubs are usually born in the winter, and most mother bears give birth to twins. Baby bears certainly look cute and cuddly, but when they're grown, they can kill an animal with one swipe of their powerful paws. Did you know that every year deer shed those beautiful branched crowns that we call antlers? They shed them because they don't need them anymore. Usually only the male deer have antlers. They use them as ornaments to attract females during the mating season. Antlers are also used as weapons, and there can be many fights among the males when they're looking for females to mate with. But when the mating season is over, deer no longer need their antlers, so the blood supply to the antlers is cut off and they dry up. The antlers then shed or drop off, and the deer wait for a new growth next spring. In the first year of a male deer's life, 2 knob-like growths called pedicles form on its forehead. In the second year, a straight shaft grows out of the pedicles, and in the third year, branches begin to appear. The pedicles are never lost, even when the antlers are shed. When the antlers are growing, they're covered with a sensitive skin called velvet. This is filled with blood vessels that feed the antlers and build up the bone. After 2 to 4 months, the blood supply is cut off by the formation of a ring around the base of the antlers. This makes the velvet wither and dry up, and the antlers shed. There are many different kinds of deer, from the huge moose to the tiny poodoo. Some have single shaft antlers, and some have as many as 11 branches to each antler. Since this number increases with age, you can tell the age of a deer by counting the branches of its antlers. You may think that the largest animal that ever existed was some kind of dinosaur, but actually, the largest animal in the world is still with us. It's the blue whale, one of a group of whales called baleen whales. The blue whale can grow up to 100 feet long and can weigh 150 tons. That's taller than a 10-story building and as heavy as a large airplane. Would you like to know some of the other giant animals living today? Click on the colors and find out for yourself. Here's a sea creature you don't want to catch on your line because it'll end up catching you. It's the whale shark, tipping the scale to almost 15 tons and 60 feet long. It's hard to find a scale big enough for an elephant, which lumbers away at up to 12 tons and over 13 feet tall. Indian rhinos are so big that one of them once derailed a train. These rhinos can reach 14 feet long and weigh up to 3.5 tons. It's no surprise that the hippopotamus is one of the largest animals. It can grow to 5 feet tall and eat its way up to 8,600 pounds. The heaviest man in modern medical history, John Bower Minnock, weighed in at 1,400 pounds. How would you like to meet a 30-foot-long, 500-pound anaconda? The African ostrich is a skyscraper as birds go. It towers 8 feet tall and can weigh 300 pounds. You've probably heard that an ostrich buries its head in the sand when it's in danger, foolishly hoping that if it can't see its attacker can't see it. Actually, ostriches don't really do this, but they do something very similar. When ostriches sense the presence of an enemy, they lie down, laying their necks on the ground and stay perfectly still. They do this hoping the enemy won't find them. But if they're discovered, ostriches get out of there, and fast. They may not be able to fly, but ostriches are the fastest running birds in the world. They can speed along at 50 miles an hour and keep it up for a full 30 minutes. Ostriches do most everything in a big way. Not only are they the fastest birds, but the African ostrich is the largest bird in the world, weighing as much as 300 pounds and standing 8 feet tall. That's as high as the ceilings in most houses. The ostrich also lays the largest egg of any living bird, measuring 5 to 6 inches across and 6 to 7 inches long. You may find this hard to believe, but ages and ages ago, birds looked more like reptiles. Instead of feathers, they had scales. When baby birds first hatch, they're covered with soft down, but soon they grow regular feathers that are suited for flying. Different birds have different types of feathers, depending on their lifestyle and the kind of flying they do. The owl, for instance, has soft, downy feathers that help it fly silently and slowly while searching for and swooping down on its prey. The hawk needs speed to hunt. Its feathers are shorter and lie closer to the body, which cuts down on wind resistance. The duck, a water bird, has special oil glands that coat its feathers. This makes them waterproof and helps the ducks to float. And the kiwi bird of New Zealand has hair-like feathers that are only 2 inches long. It can't fly at all. The upper, more slender part of the feather is called the shaft, and the lower part is the quill. The quill is hollow and has a hole at the tip where nourishment enters while the feathers are growing. The stiff part of the feather is composed of the same substance as a horse's hoof. The bright colors that birds often feature are sometimes caused by pigments within the feathers themselves. The food birds eat may also affect feather color. For example, if you feed cayenne pepper to yellow canaries just after they hatch, their feathers will grow to be deep orange, and flamingos get pinker the more pink shrimp they eat. Have you ever seen a male peacock fan out its splendidly colored tail? The way he struts around, showing off his bright feathers, gave birth to the expression, proud as a peacock. However, the female peacock, called a peahen, is rather plain-looking. It's the male peacock who displays his magnificent feathers in an attempt to attract a peahen during mating season. Lots of male birds do a sort of dance or fluff their feathers to attract female mates, but the peacock definitely puts on the most colorful show. By the way, people often think those beautiful feathers are the peacock's tail, but they really grow out of the lower back. The tail lies behind them and props them up for support. The peacock first came from Asia and the East Indies. There are two species of these birds, and they're both related to the pheasant. Peacocks have been known and admired since ancient times. Both the Greeks and Romans believed the peacock was a sacred bird, but that didn't stop the Romans from eating it. Want to win an easy bet? Just ask someone where penguins live. You see, most people think that penguins live at the North Pole, but actually they live at the South Pole, in Antarctica. They also live on the nearby coastlines of Southwest Africa, Southern Australia, South America, and islands near the Antarctic such as New Zealand. People have always been particularly fond of penguins, maybe because they look like comical little men waddling around in tuxedos. There are 17 species of penguins today. The largest is the emperor penguin, which stands 3.5 feet tall and weighs 80 pounds. But in prehistoric times, penguins were 6 feet tall and they were able to fly. Thousands of years ago, these little men in tuxedos soared through the air just like any other bird. But over the course of ages, their wings changed to short flippers. Why? Well, in remote Antarctica, penguins had few enemies. They could swim or walk about without fear of attack. They didn't really need to fly. What they did need to do was to swim and catch fish. So, after many generations of never flying, the penguin's wings began to change and adapt. Today, the penguin's short, stiff wings are useless for flying, but they make an excellent paddle for the penguin's swimming and diving feats. Penguins have also developed a thick layer of fat, which protects them from the icy waters they swim in. Whenever you see a picture of Tyrannosaurus rex, it usually has its mouth open, baring its razor-sharp teeth, or dining on some unlucky neighbors. Tyrannosaurus rex, from the Greek meaning tyrant, lizard, and king, was one of the largest and most ferocious of the dinosaurs. This giant meat-eater lived approximately 135 million years ago, reaching 18 feet in height, 45 feet in length, and weighing 7 tons. That's bigger than a double-decker bus. It tore the flesh of its prey with a series of dagger-like teeth that were up to 6 inches long. Even worse for its victims, these teeth had serrated edges, like a steak knife. Tyrannosaurus also had large, powerful back legs with claws on its feet that it used to grip its prey. It also had tiny front limbs, so small that they may have been of little use. Considering its size and strength, it must have been a mighty hunter and a true king of its time. Reverend Dr. Robert Plott found the first dinosaur fossil in 1676. It was the lower part of a large femur, that is, a leg bone. But he didn't know what it was, and the bone has since been lost. Today, we think it might have been the thigh bone of the giant Megalosaurus. Fossils have been continually discovered since then, but it wasn't until the 1800s that people began to make serious, concentrated studies of them. One of the largest finds of fossils is in Los Angeles, California, at the La Brea tar pits. In the prehistoric times following the time of dinosaurs, tar covered the area, and a thin layer of water covered the tar. Animals would come to drink the water, walk out into the tar, and get stuck. They died in the tar, and now their bones are discovered almost every time a scientist digs there. The Stegosaurus was covered with so much armored plating that it looked like a tank. It probably needed all that protection because the poor beast had a brain about the size of a walnut. Stegosaurus was about 20 feet long and weighed around 3 tons. The Stegosaurus had a double row of triangular plates running along its neck, back, and tail. It also had sharp spikes on its tail. But it was a plant eater, so despite its ferocious appearance, it wouldn't have been a danger to any other creature. But luckily, Stegosaurus had all that armor to protect itself against the bigger, faster, meat-eating dinosaurs. Stegosaurus lived during the Jurassic era, an age that started about 180 million years ago. Do you know what eras your favorite dinosaurs lived in? Well, fasten your seatbelt and get ready for a trip through time and a lot of tongue-twisting dinosaur names. Click on the bone and find out more. The Heterodontosaurus, a dinosaur that measured only 3.5 feet long, lived during the Triassic period, about 225 million to 180 million years ago. 180 to 160 million years ago, in the Lower Jurassic era, early dinosaurs called Scelidosaurus and Megalosaurus could be found. Between 160 and 136 million years ago, Diplodocus inhabited the Upper Jurassic Age, along with the Plesiosaurus, a swimming dinosaur, and Archaeopteryx, the earliest known bird. By the Lower Cretaceous time, 135 to 100 million years ago, iguanodons and hypsilophodons lumbered around. In the Upper Cretaceous age, 65 to 100 million years ago, Tyrannosaurus rex roamed the Earth, while Pteranodon, one of the largest flying animals that ever lived, soared in the sky. The Quaternary period, about 2 million years ago, saw the first human beings. If dinosaurs existed millions of years before any human beings, why are we so sure that they existed? Well, everything we know about dinosaurs comes from studying their remains, called fossils. The most common fossils are petrified bits of bones, teeth, and claws, and other hard body parts. Scientists study these remains to figure the dinosaur's size, what it ate, and how it lived. There are also fossils of footprints that hardened over thousands of years. From these prints, scientists can figure out the size of the foot and leg and whether the dinosaur walked on 2 legs or 4. But we usually only find 1 or 2 bones in the same place, so it's hard to know exactly what dinosaurs looked like. We have to study the bones we have, along with what we know about animal anatomy, and more or less make an educated guess. This early drawing shows just how much our guesses have changed over the years. In the early 1820s, people began to find a lot of fossils that were bigger than any animal they knew of. In 1842, Sir Richard Owen first used the term Dinosauria to describe these peculiar creatures. He contacted a sculptor named Waterhouse Hawkins and commissioned him to build models of 3 dinosaurs and some marine creatures. The models were to be displayed on the grounds of the great glass exposition building, the Crystal Palace. Just before the models were completed, Owen held a dinner for 21 of Great Britain's leading scientists and scholars. With the hall entirely filled with these gigantic models, the dinner table was specially arranged inside a partially completed iguanodon. These early models looked quite different from the way we now picture dinosaurs, but they're still standing, and you can go see them at the Crystal Palace just outside of London, England. You may feel colder in an icy breeze or take off your shirt on a hot day, but your basic body temperature won't change from the standard 98.6 degrees. That's because humans, like all other mammals, such as cats and dogs, are warm-blooded. Warm-blooded means that our body temperature stays constant, despite changes in the temperature of the air around us. But there's another group of creatures that are cold-blooded. Their temperature goes up or down with changes in air temperature, although their temperature tends to be slightly lower than that of the air. Cold-blooded animals include insects, lizards, tortoises, frogs, and fish. Normal body temperatures can vary quite a lot, depending on the animal. Click on the thermometer to find out more. The opossum is a marsupial with a body temperature of 94.5 degrees. Human beings prefer to keep a comfortable 98.6 degrees. It may be cold where the polar bear lives, but its body temperature is a nice, warm 99.7 degrees. Your pet dog's temperature is about 100.8 degrees underneath all that fur. Most pigs run a temperature of about 101.5 degrees. Don't be surprised if your pet duck runs a temperature of 107.8 degrees. 108 degrees is the normal body temperature for pigeons. You know that pesky bug that annoyed you all summer long? Well, it's got a whole bunch of relatives, too. No other class of animal on Earth has as many varieties as insects. In fact, there are between 2 and 4 million different kinds of insects. The only way scientists can even begin to count the insect population in one area is to count all the insects that can be found in and on a square yard of rich, moist soil. That can be anywhere from 500 to 2,000 creatures. It is estimated that around 4 million insects live in a single acre of good soil. That's about the size of a football field. Most insects are too small to notice, and some are even microscopic. When you think of the amazing number of insects that exist at any one time, you realize that we really move through a world of insects. We just have no idea that most of them exist. Most insects have 6 legs, a body that's divided into 3 sections, and 2 pair of wings, although some have different numbers of wings or legs. In fact, some bugs are so different that they're not classified as insects at all. Click on a picture to find out more. Flies have large compound eyes and movable antennae on the head. It might be hard to see the second pair of wings, but they're there. They look like little knobs and they're used for balance. Any type of grasshopper that has short antennae is called a locust. Since biblical times, locusts have been known for moving around in great swarms and destroying acres of plants. Dragonflies hold their legs together while they fly, forming a sort of basket that traps their prey. 300 million years ago, prehistoric dragonflies had wingspans of 30 inches. You can find mites living on plants and animals all over the world, but like ticks, they are not really insects. Adult mites have 4 pair of legs and a head and abdomen that are fused together. Most ants are wingless, but they're still insects. They live all over the world and are very social. They like to live with lots of other ants. Do centipedes really have 100 legs? Nope, and they're not insects either. They only have 1 pair of legs per body segment and little or no sight. A young centipede may only have 7 pair of legs and an adult between 15 and 170 pair. Beetles live on land and water on every continent except Antarctica. Their hard front wings aren't used for flying, but to protect the more delicate flying wings behind them. You may think that ticks are insects, but they're actually closely related to spiders. They suck blood from people, animals, and birds and can carry diseases like spotted tick fever. The adult female mosquito sucks blood from warm-blooded animals and leaves those itchy bites. Some mosquitoes also carry dangerous diseases, such as malaria. Did you know that spiders have 8 eyes? They live all over the world, and although they are poisonous to their prey, only a few are dangerous to human beings. Consider the amazing fly, buzzing around without a care, always just a step ahead of the fly swatter, and with the amazing ability to walk on the ceiling. How do they do this? Well, the fly has 3 pair of legs that are divided into 5 parts. The last part is the foot. Sticky pads located under the claws on the foot allow the fly to walk upside down in the ceiling or anywhere else it likes with the greatest of ease. But despite this wonderful talent, the common housefly actually spends its entire life within a few hundred feet of the area where it was born. A fly's feet are not the only complex part of its tiny body. Flies have twice the number of eyes that we do. They have 2 compound eyes made up of thousands of lenses and small simple eyes on top of their heads, looking straight up. Their feelers or antennae are not used for touch but for smell. A fly can detect odors at great distances. A housefly's tongue is a long tube, like a sponge, which soaks up juices. Its body is divided into 3 parts: head, thorax, and abdomen. The thorax is striped and has 3 pair of legs attached to it. A fly has 2 transparent wings with small knobs behind them that help it stay balanced in flight. Flies love to eat decomposing organic wastes, like your garbage. You might think that insects are just too small to have hearts, but they do, although their hearts are very different from ours. An insect's heart is a long tube running along the top of its body, right under the skin. The heart opens up just under the brain where blood flows out and runs freely. On its way through the body, the blood delivers digested food and takes away waste material. In some insects, such as the cutworm and mosquito larvae, you can see the tube-like heart beating along its back. You might notice that the heart beats faster when the insect is warm than when it's cold. As a matter of fact, it can go from 140 beats per minute in an active insect to 1 beat per minute in a very slow insect. That's because insects are cold-blooded, and it takes activity to warm them up and increase their heartbeat. Not only do insects have hearts, but they also have brains, although they're very primitive compared to the complex human brain. Unlike the human brain, which allows us to think and make decisions, the insect's brain works automatically, and its actions are involuntary. That means it doesn't have to think about them to make them happen. An insect's brain is simply a large nerve in the center of its head. It receives sensations and sends messages to make certain muscles work. By the way, considering their size, insects are amazingly strong. That's because they have many thick muscles. In fact, they often have more muscles than we do. We have about 800, while a grasshopper has about 900 muscles. Those muscles, coupled with a tiny, lightweight body, are why a grasshopper can jump so far. You may think that a chameleon disguises itself as craftily as a private eye, changing its color in order to match its surroundings. Not true. It does change its skin color, however, depending on the temperature of the surrounding air, its emotional state, and how light or dark it is outside. Here's how. Just beneath the chameleon's transparent skin are layers of cells that contain yellow, black, and red coloring matter. When these cells expand or contract, the chameleon changes color. Fortunately for the chameleon, its skin colors help it to blend into the surrounding environment. That makes it very difficult for its enemies to see the chameleon. Since the chameleon has few other defenses, the best thing it can do to stay safe is exactly what it does best: hide. What do you think makes a chameleon turn different colors? Click on the colors to see. You can tell an angry chameleon by its dark colors. On a hot but sunless day, you might find a chameleon in green attire. In the hot sun, a chameleon prefers to be very dark, almost black. If it's frightened or excited, it turns paler colors with yellow spots. In the cool of the evening, this little animal has a range of green shades to choose from. In the dark night, when it may be a little safer than during the day, the chameleon sports a cream color with yellow spots. It's hard not to admire the beautiful colors and patterns of many snakes. But pretty or not, some snakes are poisonous. There are over 2,000 kinds of snakes. They live in almost every area of the world, on land, underground, in trees, even in water. One of the deadliest snakes is the king cobra. Found in Asia, the king cobra can kill an elephant in 4 hours. The tiger snake of Australia has an extremely potent venom that it uses mostly on frogs, rodents, and other snakes. In the United States, there are only 4 types of poisonous snakes. One is the coral snake, a member of the cobra family which lives only in the south. The cottonmouth or water moccasin lives in the southeast, and the copperhead lives in the eastern states from Massachusetts down to Florida. But the rattlesnake can be found in nearly every state. There are about a dozen different types of rattlesnakes, and they all make an unforgettable rattling sound with their tail. You know that a rattlesnake has to do more than shake its rattle in order to harm you. It has to bite you. Poisonous snakes have special teeth called fangs in their upper jaws. The fangs are hollow and have an opening at the tip. They're attached to poison glands in the snake's head. When a snake strikes its victim, it injects a poisonous venom. The venom either kills the prey or makes it unconscious before it's eaten. Did you know that if a snake loses its fangs, it's still dangerous? That's because it will eventually grow those fangs back and use them again. With their darting tongues and lightning-fast movements, some lizards can be frightening. But out of 2,500 different kinds, only 2 are actually poisonous. They're the Gila monster, which lives in the American deserts, and the beaded lizard of Mexico. The rest are quite harmless. The lizard is a relative of the snake, with cold blood and a scaly skin. Lizards' bodies are divided into 3 parts: the head, trunk, and tail. Most have 4 legs, although some have no legs at all and look just like snakes. And here's an odd defense that many lizards have against enemies. They can break off their tails. While an enemy is busy gnawing on the tail, the lizard can flee to safety. Eventually, its tail will grow back again. Lizards come in many different colors. Those who live in colorful grassy or tree areas are brightly colored. Lizards that live in the desert feature the paler colors of that landscape.
Want to hear a tall tale? Come inside and hear about my broken records.
Tennis, anyone? I'll see you in court.
Quit horsing around. Race inside to find out how movies began. I'm sure my name will ring a bell. Call on me inside.
Hustling across a court to toss a large, round ball through a high hoop is a relatively young sport. But since its invention by James A. Naismith in 1891, basketball has become one of the most widely played and watched sports in the world. Naismith wanted an indoor game for his students at the Springfield Training School in Bloomfield, Massachusetts. So he combined the Indian game of lacrosse with the English game of soccer and invented basketball. He instituted dribbling and passing, and he used a wooden peach basket for a goal. Today, of course, we use a net and a rim attached to a backboard. If there's no basket available, a peach basket will still do just fine. But be sure to take out the peaches first. He was 6'3" when he was 12 years old, and was 7'1" when he went to college to play basketball for the Kansas Jayhawks in 1956. Before his career was over, Wilt the Stilt Chamberlain broke more records than any other player in basketball history. He began his professional career in 1958, playing guard for the Harlem Globetrotters. He was so successful that the very next year he signed on with his hometown team, the NBA Philadelphia Warriors. He connected with more than 7 of every 10 shots he took from the floor in his rookie year, still an NBA record. Wilt later broke records by scoring 100 points in a single game. That's the average final score for an entire team. In 1972, he led the L.A. Lakers to a record-breaking 69-win, 13-loss season. In his 14 years in the NBA, Wilt Chamberlain racked up over 31,000 points and pulled down almost 24,000 rebounds, all records. The crack of a bat as it lifts a small white ball high into space, a cloud of dirt as a runner slides into home plate. All this and more makes baseball one of America's most popular sports. But is it really American? It's said that Abner Doubleday invented baseball in Cooperstown, New York in 1839. But a very similar game was played in England in the 18th century. Not only that, but an English book published in 1828 describes a game called rounder that was played on a diamond with 4 bases and had strikeouts, fouls, and home runs. And the runner could be thrown out by being hit with the ball. Rounder is so close to baseball that today we think it's probably where baseball came from. But Abner Doubleday made baseball so popular in the United States that it's called America's national pastime. Fortunately, modern players don't have to be hit by the ball to be called out. Over the years, there have been some truly great baseball players. Click on a picture to find out who these players are and what makes them so great. Ty Cobb had the highest lifetime batting average in the major leagues. He hit .367 in 5,000 turns at bat. Jackie Robinson was the first black player in the major leagues. He started as a Brooklyn Dodger in 1946. In 1973, Nolan Ryan pitched the most strikeouts in a season, 383. The next year, he tied for the most strikeouts in a game, 19. Lou Gehrig played in 2,130 consecutive games and hit over 300 for 12 years. Cy Young was a pitcher who was famous for pitching the most entire games, 751. Today, the Cy Young Award is given to the best pitcher of the season. Lou Brock holds the record for the most stolen bases in a lifetime. He stole 938 of them from 1961 to 1979. Babe Ruth hit 60 home runs in one season, including a 587-foot smash in a 1919 game against the Boston Red Sox. Hank Aaron had 755 home runs in his career, the most ever. He also had the most runs batted in, 2,297. It's fall. The air is crisp, and torpedo-shaped pigskin balls are flying through the air. Though today's football season comes in the autumn, people have been playing similar games all year round since the time of the ancient Romans. The Romans taught a football game to the English, who've been playing their version, soccer, for centuries. Football, as we know it, began in England in 1823 when a soccer player named William Webb Ellis missed a kick. Angry at his own mistake, he picked up the ball and ran with it down the field. His embarrassed team captain apologized for his unsportsmanlike behavior, but somehow the idea caught on. In England, his version of football is called rugby, named after the rugby school he attended. But in the United States, it's called football. The modern rules of football were first introduced by Glenn "Pop" Warner in the 1910s. Each of the 11 members of a football team has a different job to do. Click on any of the players to find out what they do during the game. The safeties and cornerbacks are the fastest men on the defensive team. They have to keep up with the other team's pass receivers one-on-one and keep them from catching the ball. The linebackers are the team's second line of defense. That's why they're also called the secondary. They have to block the other team's passes and tackle receivers and runners that make it past the defensive line. This is the defensive line. Their job is to go wherever the ball is and tackle the player on the other team who has it, and they can hit him hard. The wide receiver's job is to run at lightning speeds down the field and catch passes in their skillful hands. These guys are called the offensive line, and not because they have bad table manners. They keep the other team from getting to the quarterback, and they make holes in the defensive line for their running backs to go through. Tight ends have to be both tough and accurate. They've got to catch balls and block the other team's linebackers. The quarterback is probably the most important man on the field because he handles the ball on every play. He gives it to the runners, throws it, and sometimes even runs with it himself. These are the running backs, and you guessed it, their job is to take the ball and run with it. They also block and catch passes. The fiercely competitive practice of slamming a tennis ball over a net is one of the oldest sports around, perhaps originating in ancient Egypt and Persia. By 1300, it was known as la bode, and it was popular in France in the 1400s. The kings of France and England were such enthusiastic tennis players that it became known as the royal game. King Henry VIII even built a tennis court in 1529 that's still used today. Tennis was being played regularly in the United States in the late 1800s. The game as we play it now was invented in Wales in 1873 by Walter Wingfield. Lawn tennis is played on grass courts, but tennis can also be played on asphalt or clay. Today there are several famous international tournaments, and one of the most important is at Wimbledon, England. By the way, the name tennis probably comes from the French word tenez, meaning take it, play. The way tennis is scored may seem a little strange at first, but it's easy to understand once you get the hang of it. You get points every time the person you're playing against fails to return the ball from his side of the court into yours. Points are counted 0, 15, 30, 40, and game. If the game is tied at 40-40, which is called deuce, the first player to win 2 more points in a row wins the game. The first person to win 6 games wins a set. In championship play, 2 out of 3 sets wins a match in women's tennis, and 3 out of 5 wins for men. And one more thing. When someone has no score or 0, it's called love. This term comes from the French word l'œuf, meaning the egg, because an egg looks like a 0. Though cabbage today may be the center of attention when it comes to coleslaw at a picnic, for many, many years it was considered a useless plant, something like a weed. Cabbage grew wild along the seacoast in different parts of ancient Europe, but for years people never tasted it or realized how good it was to eat. Today's cabbage has one central bud and leaves that grow tightly over it to form a large, solid head. Red and white cabbages have smooth leaves. And you might be surprised that over 150 other plants have been bred from cabbage. For instance, Brussels sprouts are like miniature cabbages with a stalk and both small and large leaves. When we eat cauliflower, we're not really eating the leaves, but the flower bud that's formed into a solid mass with a few loose leaves around it. The Italians thought that cauliflower was too hard to grow, so they developed broccoli. For nearly as long as the human race has existed, people have told stories of their lives in pictures, often in the most unusual places. The Stone Age people of Europe first drew lifelike images of prehistoric animals on their caves 35,000 years ago. The first cave art was discovered in 1875. Since then, over 100 decorated caves have been found, mostly in France and Spain. One of the most famous caves is Lascaux in the south of France. It was found accidentally in 1940 by boys playing in the area. There are several rooms in the Lascaux cave, including the Chamber of Cats, filled with drawings of cats, and a room called the Shaft of the Dead Man, showing a man caught between a bison and a rhinoceros. Lascaux is now closed to the public, but people can still see other cave paintings in France, Spain, and many other places. Thousands of years after cavemen recorded their experiences on the walls of their caves, Egyptians were painting images on the walls of their tombs. Since they believed in life after death, they often painted the most important things in a man's life, like his family and possessions. The ancient Greeks were some of the most artistic people of any age. Rather than reproduce lifelike things, they painted and sculpted ideal forms in their figures of gods and goddesses. When Christianity became a major force, it brought flat designs and symbolic ideas. Now art was no longer natural or ideal. It was filled with religious subjects. During the medieval era from 500 to 1500, beautifully painted books were made by hand. Today you can see a little bit of everything at your local art museum. But some of the most modern art still reflects the ideas of our earliest ancestors. Today, you can just click a button and out pops a photograph that comes to life right in your hand. But the first camera didn't actually make pictures, it helped people draw them. The camera obscura, used from the 11th to 16th centuries, projected an image onto paper to be traced by an artist. In 1802, Thomas Wedgwood made silhouettes of small natural objects onto paper by covering it with silver nitrate and exposing it to light. But he never found a way to make these prints permanent. Joseph Niepce made the first photographic image with a camera and lens in 1816. He produced a negative or reverse image, and a few years later successfully produced a positive image on a metal plate. Finally, in 1835, Henry Fox Talbot learned how to make permanent paper photographs. Photography was a very expensive hobby until 1888, when the popular Kodak box camera was introduced, turning anyone and everyone into a snap shooter. Maybe you've seen those fragile, shiny pictures from the 19th century called daguerreotypes. They're named after Louis Daguerre, who perfected a way of freezing a camera's image onto a coated metal plate. Having a picture taken in those days was a long and boring process. You had to stay completely still for several minutes, or else the picture would be blurry. People usually sat down while a head clasp on a stand behind them held their heads steady. When the Kodak box camera came out, everyone became a photographer. But did you know that the entire camera had to be sent back to Kodak for the pictures to be developed? Kodak then developed the pictures, reloaded the camera, and sent everything back. Did you know that the first motion picture was made to win a bet? In 1879, a California stable owner wanted to prove that a galloping horse lifted all four legs off the ground at once, but it was too fast to be seen by the naked eye. So he hired Adward Muybridge to take a series of photographs. Muybridge laid wires across a racetrack. Those wires triggered a bank of 24 cameras as the horse went running by. And indeed, the photos proved that the stable owner was right. Muybridge even constructed a machine he called a zoopraxiscope, which projected these images on a screen one right after another. The first film that really told a story, The Great Train Robbery, was made in the laboratories of Thomas Edison in 1903. Pittsburgh was home to the first permanent movie theater in 1905. It only cost a nickel to get in, so they called it a Nickelodeon. You can make your own movie or series of still pictures that move, and you don't even need a movie camera or film. It's called a flip book. To make one, you'll need something to draw with, and either a memo pad or 10 or so small pieces of paper. Click on the numbers when you're ready to begin. A movie is just a series of single frames, each with a slightly different picture. Our movie is going to be about a bird bursting a balloon. Start with the first picture. Draw the balloon rising from the bottom of the page. Now, draw several pictures of the balloon on its way up the page. On your next drawing, add the bird flying in from the right. Draw several more pictures, moving the bird closer to the balloon in each one. Draw the bird's beak hitting the balloon. Now you need a small burst as the balloon pops, with the bird looking startled. Or you can make up your own ending. Put the pages together with a staple or a paperclip, but make sure that your pages go in order from first to last. Now, quickly flip the pages with your thumb. See how the pictures move? You can color in your flip book and make it like a real movie. Before Thomas Edison made the first sound recording in 1877, the only ways to hear music were to go to a concert or to play it yourself. Edison's recording machine had a cylinder that was turned by a hand crank, as well as a horn that collected the sound, much the way cupping your hand over your ear collects sound. At the other end of the horn was a blunted needle called a stylus. The cylinder was covered with tin foil, and the stylus pressed against this foil. When the cylinder was cranked, it turned round and round, making the stylus draw grooves in the foil. At the same time, sound waves entered the horn and made the stylus vibrate. It made a bigger groove when the sound was loud and a smaller groove with softer sounds. These grooves represented the pattern of sound waves made by someone talking or singing.
When I left my country home, I swore.
The greatest recording in the world doesn't mean a thing if you can't play it back. Edison accomplished playback by moving the stylus and horn back to the beginning of the groove. The cylinder was then cranked and turned, and the air in the horn vibrated just as it had when the recording was made. That moving air made a sound, duplicating the original recording. When Edison perfected his invention on that cold winter day in 1877, he tried it out by recording this well-known nursery rhyme.
Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, the lamb was sure to glow.
Do you realize that when you talk on the phone, you're using a device that was invented by accident? On June 2, 1875, Alexander Graham Bell was experimenting with a way of sending several messages over a single telegraph wire. Bell was receiving telegraph signals that Thomas Watson, his assistant, was sending from the next room. Their homemade telegraph sets were constructed from unwound clock springs made out of spring steel. Suddenly, Bell heard a twanging sound on his set. Watson had just plucked one of the springs on his set, making it vibrate. That vibration had sent a current over the wire, causing the spring on Bell's set to vibrate too. 40 short weeks later, the telephone was perfected. On March 10, 1876, Bell used his new invention to call his assistant from the workshop 2 floors below, speaking the now famous words, "Mr. Watson, come here! I want you!" Today you can talk on the phone from your car or from an airplane. How do some of these newer phones work? Well, car phones work on radio waves, which are electromagnetic waves that travel through space. Other telephones use a different kind of electromagnetic wave called microwaves, which either travel between relay towers or are bounced off orbiting communications satellites. One of the newest and most important ways to transmit phone conversations is with fiber optics. These thin, flexible glass threads transmit laser light and can be expected to give more than 100 years of continuous operation. A pair of fiber optic cables can carry up to 672 conversations. A cable of 144 fibers can carry nearly 50,000 phone calls at the same time. And a 4.5-pound spool of fibers can do the same job as 200 spools of traditional copper wire weighing over 16,000 pounds. You may think that the Liberty Bell cracked from being rung too many times, but actually it cracked the first time it was struck, when it was delivered to the Pennsylvania State House in 1752. It was recast and repaired, and finally hung again the next year. The bell remained in one piece throughout the Revolutionary War, ringing out on July 18, 1776, to proclaim the adoption of the Declaration of Independence, and in 1783 to announce the end of the Revolutionary War. From then on, it was rung on every July 4th, as well as to mark special occasions. In 1835, the bell cracked again, and again it was repaired. Finally, during the 1846 celebration of George Washington's birthday, the Liberty Bell cracked its last time. No one was able to fix it. It was taken down and set up for display in the Tower of Independence Hall in 1915. Today it's still there for anyone to see, crack and all. Did you ever wonder how the Liberty Bell got its name? When it was first made, it was just another bell, with no special meaning or name. It became a symbol of American independence during the Revolutionary War, but it wasn't called the Liberty Bell until the mid-1800s, 100 years after it was made. At that time, the abolitionists, people who wanted to free the slaves, were very active in Philadelphia, where the bell was hanging. People in Pennsylvania believed so strongly in liberty for slaves that they named the bell for their cause. Ever since then, it's been called the Liberty Bell. Money may be the root of all evil, but did you know that the early Romans coined their money in a temple? You see, they believed that the goddess Juno warned them of approaching dangers. They were so grateful for her warnings that they made her the guardian of finances. They called her Juno Moneta, from the Latin word moneo, meaning to warn. And that's the origin of our word money. The word coin also comes from the ancient Romans. They used the word kuneus, which means wedge, because their money was wedge-shaped. How did other countries name their coin of the realm? Click on the money to see. The dollar started in Bohemia, where the silver used for money was mined from a place called Joachimsthaler. In time, this became thaler, then dollar. Dime comes from the Latin word decimus, meaning tenth. A dime is 1/10 of a dollar. This is easy. The nickel was originally made of the metal nickel. Cent comes from the French word cent, meaning 100. There are 100 cents in a dollar. The English pound comes from the Latin word pondo. It also meant pound, but was used as a measurement of weight. The Mexican peso was also originally a unit of weight. So was the Italian lira. This French franc is named after the Latin words Francorum Rex, King of the Franks. The French used to be called francs, and this phrase was printed on old French coins. If you've never been to a bridal shower, you might be surprised to learn that you don't need an umbrella or a bathing suit to attend. A bridal shower is a party that's given for an engaged woman where she gets lots of gifts for her new home. It started in Holland many years ago when a young girl wanted to marry a poor miller. Her father was against the marriage. He said that if she married the miller, he would not give her a dowry, wedding money and gifts. Luckily, the miller had many friends. They all went to the girl's house, showering her with presents like kitchen utensils and linens. Now that the couple had all the things they needed to set up housekeeping, they were able to get married after all. That was the first bridal shower, and it has become a custom that's remained with us ever since. Marriage has been with us for quite a while, so it's not surprising that many of today's wedding customs come from ancient times. For instance, those fancy towers of sweetness that we call wedding cakes go back to Roman times when rich families celebrated a wedding with a special cake. It's even said that a piece of the cake was broken over the bride's head as a symbol of abundance to come from the marriage. Each guest took a piece of cake too, so they could also have good fortune in their lives. The next time you have a piece of wedding cake, think of good times to come in your life, and be grateful they don't break the cake over the bride's head anymore. Did you know that playing cards were once used to tell the future? They were introduced thousands of years ago. No one knows exactly where. It could have been in China, Egypt, or even India. Cards similar to those we use today were created in Italy around the 13th century. They were called tarot cards. This 22-card deck was used for both fortune-telling and simple games. Over time, the deck grew to 78 cards, with 4 suits and 4 court or royal cards. The French cut the deck down to 52 cards, keeping the royal king, queen, and knave, or jack. In the 17th century, they replaced the tarot's 4 suits with clubs, diamonds, hearts, and spades. Early cards were very expensive because they were handmade, but with the invention of printing, everyone could afford to have a deck. Today's picture cards still show people wearing outfits from the 15th century. In some games, the 2 jokers in your deck are more valuable than any other card. In others, you don't use them at all. Jokers come from the Italian tarot deck. One of the cards was called Il Matto, the Fool, and that's the one we now call the Joker. Today's Joker still wears outfits that the court jesters wore centuries ago. Court jesters were clowns for kings and queens. They made the members of the court forget their troubles with jokes, tricks, and odd-looking multicolored clothing. Whenever you shrug your shoulders or nod your head, you're using sign language to express yourself. People who are hearing impaired cannot always understand normal talking, and their speech is often unclear. These people use sign language much of the time. The origins of sign language for the deaf are hard to pin down. We know for sure that by 1755, Abbé de l'Épée was teaching it in his school for the deaf in Paris. His system eventually became the manual alphabet. Manual means hand, and in the manual alphabet, finger positions represent letters. Some people can spell out words at the rate of 130 a minute. Today, sign language is a system of signs that stand for whole words and phrases. For instance, this means, "You're not telling me the truth." However, the manual alphabet is still used to spell out words for which there are no signs. Before Samuel Morse invented the telegraph in 1837, people had to trust all sorts of methods to deliver messages quickly over long distances. But Morse didn't just invent the telegraph. He also created the Morse code, a standard system of sending letters and numbers over telegraph wires. Morse code consists of a series of short sounds called dots, like this, and long sounds called dashes, like this. They're made by using a switch to interrupt a continuous electrical current. Together, dots and dashes make up letters and words. Here's a famous signal in Morse code. It's the letters SOS, which stand for Save Our Ship. SOS is the International Emergency Signal. Although these days long-distance communication is done by telephone, fax, or computer modems, Morse code is still used for some ship-to-shore transmissions and in amateur radio. Have you ever played a game where you were blindfolded and had to make your way around without the use of your eyes? Well, that's what it's like for blind people all the time. But this doesn't mean they can't read. The Braille system is a method of reading and writing by touch for the blind. Braille was devised by Louis Braille, who was blind himself and a teacher of the blind. He invented an alphabet of dots which are raised off the paper. Blind people can train their sense of touch to be so acute that they can read by running their fingers over the dots. Each letter is a different combination of dots, up to 3 dots high and 2 dots wide. For instance, this is the pattern for the letter A. Braille can be written using a special punching instrument and paper, or by using a Braille typewriter. Today, there are thousands of Braille books and magazines.
I am Count Sanguine, but you can call me the Blood Count. Are you my type? Come inside and find out.
If you want to know the long and the short of it, just meet me inside. And I do mean inside.
Brush up on your dental knowledge inside. Learn the whole tooth and nothing but the tooth.
I'm Edward Jenner, and I'm sure you'll get my point inside. How do you do? I am Count Sanguine, and I'm always happy to meet a new friend. I can tell you have come to ask about my favorite food, subject, blood. I've done a lot of research on blood, and I can tell you everything there is to know about its color, its composition. I find it a very tasty topic indeed. Now, what would you like to know first? Where do you get all those billions and billions of delicious little red blood cells that I love to snack on? Well, they're made in a reddish-gray spongy substance in your bones called marrow. If you look at a cross-section of a bone under a microscope, you can see a network of blood vessels and connective tissue fibers. Between these are marrow cells, and that's where blood cells are made. When the blood cell is still in the marrow, it has a nucleus like most other cells. The nucleus controls the activities of the cell, such as creating protein and reproducing. But when the cell leaves the marrow and goes into the bloodstream, it loses its nucleus. Now, its job is to carry oxygen from the lungs to the body's tissues and to carry away carbon dioxide. Some animals have a stingy number of large blood cells, while others have a generous supply of small ones. It all depends on how much oxygen the animal needs in its body. Worms, for instance, carry oxygen in the liquid portion of their blood, not in the blood cells. Cold-blooded amphibians, like frogs, have large and relatively few cells in their blood. Animals that are small, warm-blooded, and live in mountainous regions have the most blood cells. Since there is less oxygen in the higher altitudes, these animals need more blood cells to carry that oxygen through their bodies. Blood red, my favorite color. But what makes it that way? Blood is red because its cells contain a red-colored substance called hemoglobin. Hemoglobin produces the red color when there's oxygen in the blood. When blood is on its way back to the lungs, it contains no oxygen. Blood that's low in oxygen is gray, or a dull brownish red when it's seen through the veins. But blood is more than just red cells. The liquid part of the blood is called plasma. The plasma contains proteins, including antibodies to fight disease, fats, salts, and other substances. Still, there are so many red cells or red corpuscles that all the blood looks red. There are about 25 trillion of these tiny flat discs swimming through your blood vessels all the time. About 2 million red blood cells bite the dust every second. On the average, red corpuscles live only 4 months. Then they're removed by the spleen and the liver and eliminated with other body wastes. But new red cells are constantly being produced in the bone marrow, so there are always enough red blood cells in your body. Isn't that a relief? For me too. You will most likely always have enough blood in your body, even if you cut yourself and lose some. In fact, when you do get a cut, cells called platelets make the blood thicken into clots. Then the clot hardens and forms a crust, or scab. When the skin underneath the scab heals, the scab falls off. The human body could never contain enough blood to suit my tastes, but for your uses there's plenty. An adult body contains a little less than 6 quarts of blood. In a single drop of blood there are around 300 million red cells. In fact, if all the blood cells in your body were joined together in a chain, they would stretch 4 times around the earth. Every second, 2 billion blood cells pass by the air chambers of the lungs, picking up oxygen to bring to all the organs of the body. And did you know that people who live in high altitudes have more blood cells? That's because the air is thinner at higher altitudes. That is, there's not as much oxygen in it. The body makes up for this by producing more blood cells to bring enough oxygen to the organs. So, a person living in the Swiss Alps may have 25% more blood cells than a person living in Los Angeles. Did you know that blood comes in 4 flavors? I mean types. There are 4 main blood groups, A, B, AB, and O. People with AB or AB types of blood have a certain protein in the red cells. People without this protein have O-type blood. It is important to know which type you are, because if you ever need a blood transfusion, you have to get a blood type that's right for your body. AB is the rarest type of blood, and O is the most common. Hospitals always test for blood type to make sure you're getting the kind you need. People with AB blood can use blood from all other groups, and anyone can use blood type O. There's also a protein in the blood called the Rh factor. People with this factor are called Rh positive, and those without it are Rh negative. Usually, it doesn't mean much to us, but it can lead to trouble if the 2 types mix. Although white blood cells aren't nearly as tasty as red ones, they're still very important to your body. White cells, called leukocytes, fight infection and disease. One form of leukocyte is the granular cell or granulocyte. Granulocytes are your body's first line of defense. They can go to the spot where germs or injured tissue have collected. There, they destroy bacteria by eating it. When they die, they turn into pus. Pus is just a collection of dead white blood cells. Another form of leukocyte, known as monocytes, also destroys bacteria and other foreign material when there is an infection. Together with other cells in the tissues, monocytes remove dead and damaged tissue to keep them away from healthy tissue cells. Monocytes control other white cells called lymphocytes. When there is infection, lymphocytes increase in number and produce chemicals called antibodies. Antibodies help fight off the infection. As far as I am concerned, you can have as many white blood cells as you like. but your body might disagree. Having too many white blood cells is a sign of leukemia, also known as cancer of the blood. When someone has leukemia, his white blood cells just continue to divide and reproduce, and they don't grow into the healthy active cells that are needed to fight off infection and disease. Modern medicine has many ways of dealing with leukemia, and it's not always the killer disease it once was. But it's still deadly in many cases, and scientists are hard at work trying to find a true cure, and even a possible prevention for leukemia and other forms of cancer. Blood pressure is that little twinge you feel when I nip your neck. Just kidding. It's really a measure of how strongly the blood is flowing through your veins. Blood pressure is created when your heart contracts to pump blood through the arteries and around the body. These contractions produce pressure, like the pressure of water in a shower. And that's what we call blood pressure. Your blood pressure can be measured by an instrument with a wonderful name, a sphygmomanometer. A sphygmomanometer is that inflatable cuff the nurse wraps around your upper arm. There's a rubber bulb attached to the cuff by a tube, and when the bulb is pumped, the cuff inflates. As the air is released, the nurse or doctor measures your blood pressure. Blood pressure is measured in millimeters of mercury. Normal blood pressure for an adult is about 120 over 80 millimeters of mercury. Your blood pressure isn't always the same. It goes up when your heart is contracting and drops when your heart is resting. The contracting pressure is called systolic pressure, and the resting pressure is known as diastolic pressure. Your blood pressure reading contains both measurements, systolic over diastolic. So, a reading of 150 over 90 means 150 millimeters of pressure when the heart is contracting and 90 millimeters of pressure when the heart is relaxing. Doctors don't all agree about what readings mean that your blood pressure is too high, but experts say that in general, blood pressure higher than 150 over 90 millimeters of mercury is too high for most adults. High blood pressure can produce headaches, dizziness, and the feeling of tiredness, among other things, and must be treated by a doctor.
Have you ever wondered why you don't wear down your teeth from all that chomping, chewing, and brushing all day long? It's because your teeth are hard as a rock. Teeth are made up of mineral salts, mainly calcium and phosphorus. Every tooth has two parts. The roots anchor it to the jawbone, and the crown is the part that can be seen in your mouth. The crown is covered with a hard, shiny substance called enamel. A bone-like material called cementum covers the root. Dentine, an ivory-like substance, forms most of the tooth you see in your mouth. There's a hollow space inside each tooth called the pulp cavity, where there are nerves, veins, and arteries. These enter the tooth at the root end. So even though your pearly whites are hard as a pearl on the outside, they are very sensitive on the inside. So give them proper care, and they'll continue to give you something to smile about. The 32 teeth in your mouth come in 4 different shapes and sizes, and each has a different job to do. Click on any tooth to find out about its job. These big teeth in the back of the mouth are molars. They grind up food to get it ready to swallow. These are the bicuspids, also called premolars. They tear food and crush it as well. The cuspids, also called canines, have sharp, pointy crowns. Their job is to tear the food. The big teeth in the front of your mouth are called incisors. They specialize in cutting off bites of food. You've probably noticed that your teeth are different from your cat's teeth or your dog's. Every animal, man included, has teeth particularly suited to its way of life and the food it eats. Beasts of prey, meat eaters, usually have sharp, tearing teeth. Cows and other plant eaters have grinding teeth. Man has what is known as collective dentition, which means that he has many different kinds of teeth, one alongside the other. Scientists say this shows that the human body is suited to a mixed diet of meat and plants. They're especially interested when they find a fossil tooth because it can be an important clue as to whether an extinct animal was a meat eater or a plant eater. We can look at the teeth of modern animals to tell us about their diet habits. Pick an animal and find out what it eats. The beaver has long, gnawing teeth, great for chewing through trees. Some snakes' teeth are set inward at an angle. That gives them a strong bite that is impossible to escape. The squirrel has strong, gnawing teeth that can even cut through the hard shell of a nut. Now, don't try this trick at home. Have you ever noticed a dog's long, sharp front teeth? These teeth can catch and hold prey. The sharp back teeth are used to cut up flesh and bones. Some sharks have blunt teeth for crushing shellfish. Others have sharp, cutting teeth for eating fish. The pike has movable teeth. They fold backward as food is swallowed, then straighten up again. You've probably heard that eating too much candy causes tooth decay. But do you know why? It's because the bacteria in your mouth feed on the sugar. Decay usually begins with a small defect in a tooth's enamel. Bacteria in the mouth produce acids that dissolve the enamel and the dentine underneath. This may eat away the dentine and create a cavity, which is just another word for a hole. When the hole enlarges and gets close to the pulp cavity, nerves inside the tooth become sensitive to heat and cold. If the decay continues and the acid eats into the pulp cavity, you get a toothache. When bacteria infect the inside of the tooth, eventually the vessels that supply food to the tooth wither away, and the tooth dies. You can even see this bacteria when it builds up on a tooth. It's called plaque. Brushing your teeth well every day is one way to get rid of bacteria and prevent tooth decay. Everyone can take steps toward preventing tooth decay, and the earlier you start, the fewer trips to the dentist you'll need. Fluoride is a strong decay preventative that works by strengthening the enamel. There may be fluoride in your drinking water and in the toothpaste you use. It's also important to use your toothbrush properly. And try to brush after every meal. If you can't, try rinsing out your mouth with water or even eating an apple. They both reduce the amount of bacteria on your teeth. Try to stick to a diet low in sugar because sugar helps cause cavities. And here's a helpful hint. If you eat candy, eat it with other foods so that the sugar in the candy can't coat your teeth. Also, ask your dentist about flossing and other ways to prevent cavities. When astronauts go into outer space, they take a supply of oxygen with them. But here on Earth, all you have to do is take a deep breath of air. When you breathe in through your nose, the air is warmed, cleaned, and then goes down the windpipe. In the chest, the windpipe splits into 2 bronchial tubes, each heading to a different lung. These tubes branch into even smaller ones, and each of the tiniest tubes opens into a cluster of thin-walled air sacs in the lungs. The air sacs are bunched like grapes and are surrounded by tiny blood vessels called capillaries. The capillaries are filled with blood that has just made its rounds through the body and now contains carbon dioxide. The carbon dioxide passes from the blood into the air sacs, and the blood fills with oxygen. The heart then pumps blood throughout the body, bringing the oxygen in the blood to the other organs and cells. So where do you think we get all this oxygen that we need to stay alive? Well, believe it or not, it all comes from plants. Plants breathe too, in a way. Through small pores in their leaves, they take in the carbon dioxide that we breathe out, and then they release the oxygen that we breathe in. So plants and animals need each other for survival. In fact, there couldn't be any oxygen-breathing life on this planet without plants. Do you know people who are on diets because they think they're too fat? In our efforts to keep our bodies trim and fit, fat has gotten a bad name. But we need a certain amount of fat. Fat serves as stored food for our bodies. When we don't eat enough food, our body begins to use its fat reserves instead. Fat is the most efficient energy food that we know. It produces more heat than an equal amount of sugar, which is the body's normal daily fuel, and has about twice the energy value of sugar. The normal male body contains about 10% fat, while the normal female body has about 25%. But this doesn't mean that you would look overweight. Fat only begins to show when you're storing a lot more than your body needs. That's the kind of fat people want to diet away. Aside from its use as stored food for energy, fat does several other important jobs in our body. First of all, fat helps to keep us warm. It's also very good padding for our bones because when fat is squeezed, it bounces back instead of squashing in. That protects our skeleton from bumps and bruises, which might otherwise break bones. Perhaps you've never thought about it, but we don't have fat on all parts of our bodies. We usually don't have fat in our ears, nose, forehead, or at the joints of our bones. But we do have fat in our buttocks, cheeks, the area our eyes rest in, and the palms of our hands. Just think, if you didn't have enough fat on your rear end or the bottom of your feet, just sitting on a chair or walking around the house would be awfully painful. If you've ever seen a picture of intestines, you might have thought they looked like a bundle of giant sausages. But your intestines do the important job of breaking down the food you eat so your body can get energy. Our small intestines are 23 feet long. Not very small at all. In fact, that's more than twice the distance from the floor of a basketball court to the rim of the basket. The walls of the intestines are mostly muscles. Food travels first through the small intestines, which are made up of a series of loops. The food stays in each loop for about a half an hour, while digestive fluids work to break it down. Then the food is absorbed by the body. By the time the food goes on to the large intestine, it's already been mostly digested. The large intestine breaks down the coarser parts of the food we eat, such as fruit skins, and extracts valuable vitamins that our bodies need. The inner walls of your intestines are lined with millions of tiny delicate fibers called villi, which make the surface look almost like velvet. Among the villi are 20 million tiny glands that release 5 to 10 gallons of digestive fluid into the intestines to break down food. When the food leaves the small intestine and goes to the large intestine, most of the nutrients have been absorbed. In the large intestine, water is absorbed, and bacteria break down the digested food into needed vitamins. By the way, the large intestine is between 3 and 15 feet long, much shorter than the small intestine. So why is it called the large intestine? Because the diameter, its thickness, is larger than that of the small intestine. You probably don't give swallowing a second thought, especially when you're enjoying your favorite foods. But swallowing is actually a complicated process with a lot of steps. First, your teeth cut and grind the food, which is mixed with saliva. The tongue forms the food into a soft mass called a bolus. As the food heads for the throat, the soft palate in the roof of your mouth raises to block the food from going to your nose instead. Now the food starts down the pharynx. Here the epiglottis, cartilage at the back of the tongue, covers the top of the windpipe, which is for breathing. The food then goes into the esophagus, a 10-inch tube surrounded with strong muscle which forces the food into the stomach. You know what happens when food goes down the windpipe instead of the esophagus? You start to cough. That's what's called going down the wrong pipe. You know how you squeeze toothpaste out of a tube to brush your teeth? Well, the muscles of the esophagus push food toward the stomach in much the same way. The walls of the esophagus have muscle fibers that contract and push the food along. Nerve endings in the esophagus tell the muscles when to contract. Liquids go down quickly, but solids take about 8 seconds. So you see, swallowing isn't just a matter of food dropping down into your stomach. It takes strong muscles to force it down. That's why it's possible to eat while you're lying on a couch or even upside down. And that's also how astronauts can eat and drink in outer space, where there's no gravity. You can't feel your hair grow, and you can't see it grow, but you sure can tell it's grown when the hair that used to be brushed back over your ears ends up in your eyes. Your hair grows rather slowly, about ½ inch a month, or about 6 inches a year. Of course, everyone's hair grows at a slightly different speed, and hair doesn't grow forever. It will only grow to be so long, and then it stops. However, this length is different for everyone. Here's a funny way to think of it. If all the hair on an adult's body, not just the head, grew in a sort of a hair cable rather than in individual hairs, do you realize that the hair would grow 6 inches every 5 minutes? That adds up to 37 miles in a year. Just imagine how busy that would keep the local barber. Even hair has to rest every now and then, so it doesn't grow at the same rate all the time. When does it rest? Click on one of the clocks to find out. When you wake up, your hair begins to grow faster. It grows at its fastest pace between 10 and 11 in the morning. From late morning to mid-afternoon, your hair growth slows down and sort of takes a nap. Maybe that's because of all the work it did early in the morning. At night, your hair grows very slowly, but then everything else in your body slows down too. Why should hair be different? In the late afternoon, your hair suddenly starts speeding up again. Did you know that we receive 80% of all our information through our eyes? The human eye is like a ball-shaped camera with a little bulge at the front. There's a hole in that bulge called the pupil, and it looks black because it opens into the dark inside of the eye. Surrounding the pupil is the iris, a colored ring that opens wide in low light and becomes smaller in bright light. The iris controls how much light comes through the pupil and into the lens of the eye. The lens focuses the light and projects a picture on the back of the eyeball. Here at the retina, 130 million light-sensitive cells send messages through the optic nerve to the brain. Though the eye is smaller than a ping-pong ball, it can process more than 500,000 messages at one time and send them to the brain at the speed of 300 miles per hour. That's almost as fast as a speeding bullet. Our eyes don't allow us to see all by themselves. Our brain has a lot to do with it, too. It's the brain that interprets the light and tells us what we're looking at, how far away it is, how fast it's moving, and everything else we need to know when we're looking around. Not only that, but the lens in your eye turns images upside down. It's your brain that turns the information right side up and figures out what it is. And how do we know what color things are? Color messages are thought to be received only as red, green, or blue. Your brain processes the combinations of these colors and comes up with all the colorful variations that you know. You say you like pizza? Did you know that when you say you like the taste of a food, you're also saying that you like the smell? That's because both your tongue and your nose work together. Your tongue uses taste buds. You can see them if you look in a mirror. The taste buds in the back of the tongue are most sensitive to bitter tastes. The ones on the sides sense sour and salt. The tip of your tongue picks up sweet flavors, and the center of your tongue has no taste buds at all. But at least half of what seems like taste is actually smell. To prove this, just blindfold a friend and have him pinch his nose so he can't smell anything. Then have him bite into an apple and a pear. He'll have a hard time trying to tell the difference. Now trade places and have him do it to you. You'll be surprised at how difficult it is to identify different foods. Other animals have taste buds too, but some have more than others. Click on a color to find out more. The antelope has 50,000 taste buds, more than enough to know how to appreciate a really good meal. The cow has 35,000 taste buds. That's a lot of taste buds just to enjoy grass. Human beings have 10,000 taste buds, and although we have only 4 taste sensations, together they make up the wonderful variety of tastes that we enjoy. The pig has 5,500 taste buds, and even with all those taste buds, pigs will eat almost anything. The whale swallows whole schools of fish without even chewing them. Not much point in having many taste buds. It has very few, if any. The whale swallows whole schools of fish without even chewing them. Not much point in having many taste buds. It has very few, if any. You probably don't look forward to a doctor poking a needle in your arm, but vaccinations are important because they contain medicine that prevents you from getting certain diseases. How does it work? Well, your body has the ability to stop you from getting some illnesses. This ability is called immunity. How do we get immunities? Sometimes by catching certain diseases like measles, smallpox, and chickenpox. Then the body builds up a lasting immunity, and you rarely get those diseases again. So scientists have developed vaccines made of weak forms of the virus that causes a disease. With an injection of vaccine, a vaccination, we fool our bodies into thinking that we actually have the disease, and our bodies develop an immunity to it. Then, when we're really exposed to the disease, we're already immune, and we don't get sick. The first vaccine was developed by an English doctor named Edward Jenner. Jenner lived during the 1800s when many people were dying of smallpox. Cows got a similar disease called cowpox, but it wasn't as dangerous as smallpox. Now, it seemed that people who were exposed to cowpox, particularly farmers who spent a lot of time milking cows, appeared to be immune to smallpox. So Jenner inserted the matter from a cowpox sore into 2 cuts on the arm of a healthy 8-year-old boy. The boy then became infected with cowpox. 48 days later, Jenner introduced smallpox into the boy's arm. Sure enough, the boy didn't get smallpox. Today, we have vaccines against many diseases that used to be fatal. A quick injection can protect us against mumps, German measles, tetanus, polio, or hepatitis B. Has anyone ever felt your forehead to tell if you were sick? They were checking to see if you were unusually warm, a sure sign of fever. You see, normal body temperature is around 98.6 degrees Fahrenheit, but your temperature rises when you're sick. Fever is a sign that your body is working harder to fight a disease. When you're sick, your body produces more hormones, enzymes, and blood cells, and this increased activity makes your temperature go up. Your blood circulates faster and you breathe more rapidly. This helps the body get rid of harmful waste faster and more efficiently, and that helps you get better. But you don't want to have a fever for too long. After 24 hours, it may start destroying body protein that's necessary for life. And a very high fever can be life-threatening. But don't worry. If need be, you can take medicine to bring a fever down. Have you ever gotten over a cold, but the thermometer said that you still weren't 98.6? Don't worry. Although 98.6 degrees Fahrenheit is considered to be average, your temperature can be as low as 97 and as high as 99.5, and you may be perfectly healthy. Some people just naturally have a higher or lower temperature than others. Also, your temperature changes in different locations in your body, and the temperature goes up and down about 1 degree every day. It's usually highest in the late afternoon and lowest after midnight. Your temperature can climb slightly on a very hot day or when you're involved in a lot of physical activity. It can even go up after you've eaten a big meal. You probably know that cancer is one of the major causes of death in the world today. But do you know just what cancer is? Cancer is the uncontrolled growth of abnormal cells in the body. You see, normal cells grow in the body all the time. They mature, die, and are replaced by healthy new cells. But cancer cells are different. They never mature. Cancer cells just stay young and keep multiplying until they harm the body by making it impossible for normal cells to function properly. So the normal healthy cells die out and the cancer cells take over. Anyone, young or old, can get cancer, so it's important to have regular medical checkups. New treatments for cancer are being developed all the time. They may include surgery, medicine, and radiation procedures. And although we still don't have cures for many forms of cancer, we are making progress, and lots of people who've had it are alive, active, and cancer-free today. Although researchers haven't definitely pinned down what starts cancer cells multiplying out of control, they do know certain things that contribute to your chances of getting cancer. Smoking, for instance, is very unhealthy and dangerous and is a major cause of lung cancer. So don't smoke when you grow up. It's definitely not worth it. Air and water pollution have also been linked with cancer. People who have been exposed to asbestos, an insulation material that used to be put in a lot of buildings, are more likely to get a type of lung cancer. And lately, doctors have been warning people about getting too much sun. Certain rays of the sun, even on cloudy or hazy days, can promote skin cancer. So be careful about too much sun tanning, and avoid getting sunburned by wearing a hat and sunscreen or sunblock lotion. Have you ever seen a pool of water shimmering on a hot street, only to discover it's not really there? Well, that's an optical illusion, a trick that our mind plays on us. It happens because seeing is done not only with the eyes, but also with the brain. The eyes are the organs that receive visual impressions, but it's the brain that tells us what we're seeing. What helps the brain make that decision? Well, it takes less energy to move the eyeballs from side to side than from top to bottom. That's why we think the horizontal line in this famous illusion is shorter. Sometimes there are several different ways to interpret the information that the eyes send to the brain. There's no right or wrong answer to this kind of optical illusion. It's just a question of which picture your brain picks up first. Here are a few well-known illusions. What do you see? You've probably guessed that although the top line seems shorter, both lines are actually of equal length. Is this hat taller than it is wide? Actually, the height and width are equal. Do you see a flower vase or the silhouette of two faces staring at one another? Don't tax your brain. They're both correct. Believe it or not, these long lines are all parallel. They are the same distance apart at the top and the bottom. It may look like the figure on the right is taller, but actually they are both the same size. Which of the two lines on the right is the continuation of the line on the left? It may look like the top line, but it's really the bottom one. Have you ever seen a black, white, brown, red? If everyone's skin serves the same purpose, to cover and protect the body, why do you suppose people have different colored skin? Well, it has to do with chemical processes in the body and in the skin itself. In the skin tissue, there are special color chemicals called chromogens. They have no color themselves, but when certain body proteins called enzymes act on the chromogens, they produce skin color. A pigment called melanin is present in everyone's skin. It has a brownish tint, and sunlight makes the body produce lots of melanin. That's why people in countries with a lot of sun usually have darker skin. Carotene, another pigment, gives a yellow tint to the skin, and all the tiny blood vessels just under the skin produce a slightly red tint. Your skin color depends on how all these colors combine in your body. All human skin colors come from these pigments, just in different mixtures. Have you ever wondered how we get suntanned? Tanning comes from the sun's action on the brownish skin pigment called melanin, the same pigment that gives us our normal skin color. When you're out in the sun, the action of the sun's ultraviolet rays speeds up production of melanin in your body. The increased amount of melanin makes your skin darker. We used to think that getting a suntan was a healthy thing to do. Now we know that too much exposure to the sun can be very dangerous. Too much sun over the course of years may cause skin cancer and give you wrinkles. Doctors recommend that you use sunblock to protect your skin from the sun, regardless of the normal color of your skin. At one time, people, especially women, did everything they could to get rid of freckles. They were considered unladylike. But nothing worked, because freckles are just another kind of skin coloring. They're produced by the pigment in the skin tissue called melanin. Melanin comes from special cells that are scattered throughout the lower layer of the epidermis, which is the thin outer part of our skin. These cells are called melanocytes. Sometimes a group of melanocytes bunch together and you get a freckle. Freckles vary in color, and they get darker in the sun. So you might as well start thinking those freckles are cute, because they're here to stay. For hundreds of years, people have been telling each other how to get rid of freckles. For instance, people used to wash their faces in watermelon juice or buttermilk. Another supposed remedy was washing with water that a blacksmith had used to cool a hot horseshoe. Or you could wash your face in dew, provided that you did it before dawn on the first day of May. Then you'd have to wash with dew 7 times that morning and 7 times for the next 6 mornings. If you preferred rubbing to washing, there was always the ripe strawberry or sliced cucumber that supposedly removed freckles when rubbed on them. But don't run out to the produce section of your local supermarket, because none of these so-called cures work. Pimples are one of the least enjoyable parts of being a teenager, but most people have to deal with them at one time or another. Sometimes people get blackheads. These are black dots which form when your skin pores get plugged up with natural body oil and hard, dead skin cells. If the pore opening is very small or badly plugged, the oil never reaches the skin surface at all. Instead, it forms a whitehead, a small whitish bump with pus in it. Acne is a condition that is very common in adolescence because hormone changes cause the skin glands to produce a lot of extra oil during the teen years. The oil usually reaches the skin surface through small tubes called pores or ducts. But if the pores are blocked, the oil can break through the walls of the ducts. This causes pimples. Luckily, pimples usually go away in a short time. But if your pimples are very severe, you should see a dermatologist, a doctor who specializes in skin problems. Most pimples are a normal, temporary part of being a teenager. But sometimes they can be a sign of a more serious skin disorder or even a disease. If you get a lot of pimples on the body, it's probably a good idea to go to the doctor. If they're caused by an internal problem, then medication applied directly to the skin won't do any good. In fact, it might damage the skin permanently. Some people squeeze pimples to make them go away, but that's a bad idea because it makes it possible for bacteria to get into other areas of the skin and cause an infection. And the pus you're squeezing out is really bacteria, dead cells, and white blood cells that have collected to fight the infection causing the pimple. To avoid pimples, it's better to try to keep your skin and hair clean. Eat a proper diet and just bide your time. You'll grow out of it.
Hey all, I have some big news. The latest Tales of Hyperia the Crimson Knight demo has been officially released. Relive the magic of classic gaming with this new retro-inspired JRPG demo designed for the Game Boy. Immerse yourself in unique pixel art, an epic quest, and turn-based battles that harken back to the golden age of RPGs. Check out the link in the description to play the demo.